So, good morning, everyone. And as you already know, we have started with the data structure and planning to learn the new topics. Obviously, what we have seen in the last session was a quick recap. I'll go through. We just begin with learning what do we mean by data structure, correct? What data structure needs, what is the data structure as an abstract data type, then a rough classification of a data structures that we have seen, right? Then we went ahead, we talked about how the efficiency of a data structure will be measured. It could be on a space front or it could be on a time front. But at the same time, it might be kind of an exact analysis or it could be like asymptotic analysis. The exact analysis usually doesn't make any sense because it is very much machine configuration dependent, machine architecture dependent. So usually we look for asymptotic analysis. And into the asymptotic analysis, we mainly look for the big O notation, which is usually representing a kind of upper bound, the maximum one, the worst case kind of scenarios that you more worry about in the real world. And then once we also take a look at the roughly what all different time complexities could be. But then this is just a conceptual discussion. So then we went ahead. We talked about like a linear search. We written algorithm, and I guess linear search was very simple. You want to start from the first element, reach to the last element, and compare with each and every element. It was very simple process. But after that, we talked about like a binary search, where each time you are dividing array into the two parts, and then you decide whether the middle element is the element that you are searching, or if the element that you are searching is greater, you say that I will focus now on a right partition, or if the element that you are searching is a smaller, then you can focus on a lower partition, left partition. Obviously, binary search do expect that your arrays are binary search do expect that your array is already in a sorted order. Obviously, since we are learning the Java data structure using Java, at times we are definitely using some of the Java functions which are like close to that, like some of the functions that we have seen yesterday. And I have directly used like arrays.sort method because I do not really want to waste my time into like sorting. Yes, sorting is definitely we can learn separately, but when the things are available ready-made at place, we have used it. Or like another method that we have used like arrays.toString method, just to print the array into the stringized form. Then once we learn basics of linear search, binary search, we talked about recursion. And I guess we had done enough of discussion on recursion, how to write the recursive program, how to how recursion programs are executed internally, what happened to that, like a mathematical front, and etc. etc. So yes, how the function artificial records are created onto the stack, and how all the way story goes. So like whole stuff we try to discuss in a step-by-step manner. And after that, we try to write the same binary search algorithm once again in like a recursive manner, saying that, okay, if the element is smaller, repeat binary search for the left partition, or if the element is greater, then repeat binary search for the right partition. And this is the probably logic that we put in. And after that, we say that now it's time that we can go ahead and we talk about the like what is that sorting algorithm. And after sorting algorithm, yes, we started discussing the selection sort first. The selection sort first. Not only we discussed the sorting algorithm, we discussed like one time, two time we are done on paper. Then we went back, we implemented in a Java code as well. And after that, I guess it is comfortable. We also seen the time complexity of the little selection sort. I told you a bit thing about what is that assignments, and then I guess now enough is done. I'm very sure you must have also done this sort of assignment. ये भी आप लोगों ने करके देखा होगा that how we can do, or like if at all you want to make a kind of a generic method, that was like one of the assignment that was made available. I'm very sure many of the concepts you might have learned in a Java. It is just matter of revision. I always believe that learning data structure in Java should help you to understand Java collection framework better. So you always use arrays.sort method, and that takes comparator for you. But then how that comparator internally works, probably if you at all want to know that how that comparator internally work, what you need, you need to probably write your own sort method and you need to call the comparator. And that is what probably the assignment was. So I always recommend that more assignments that you will be doing, you will be like bit more comfortable. Things will be tricky and better. That is the reason I'm saying that the people who are good at, basically Java and all that, they can definitely help other. They can, you people can discuss together and then come up with like some good results. I guess that is like enough of introduction. And now it's time we can go a step ahead and we can start talking about the next algorithm. Today we are planning that we will talk about like a bubble sort, then we'll talk about like an insertion sort, and after that we will move on to the linked list concepts. So linked list concepts using Java, how we can write, how we can implement it, and etc etc. Yes, we will talk about that, and we will see how much linked list that we can cover. So maximum, like there are two three types, four types of linked lists are there. Definitely we will try to cover at least one type of linked list, and usually the first linked list I spend enough time, I go bit slow so that you can do the paperwork, you can write the code with me. Anyway, now let's get started. I hope there are no questions as such. If anything is there on every day, you should not really wait. So every time you join a meeting, it is like a good time that you have got any question, you should have posted it. Anyway, let's get started with the bubble sort. Should we? Yeah. Thanks for your kind permission. And then we'll talk about what is bubble sort. What is bubble sort? Again, I'll first tell you the concept. I'll first tell you the philosophy, why it is called bubble sort. But to understand bubble sort, you must have played in water sometime. So, in your childhood, you might have played with the water, and then you might have seen that some, you just play some tricks, and then you find that some bubble is like generated at the bottom of the water. If at all you have seen some bubble is generated at the bottom of the water, you will always find that the bubble will scroll up. The bubble will scroll up, the bubble will scroll up, and that will come, on the top. So this is something that we say usually. But if you have ever noted, if you have ever noted, you must have seen that as bubble just start growing, as bubble start coming up, it grows in a size, and then when it is probably at the surface, like at the highest size. This phenomenon, if you ever seen it, I would say that the bubble sort do something similar one. So what exactly it does? The bubble sort, you start scrolling. You start scrolling means what? You start comparing two consecutive elements. You start comparing two consecutive elements, then next two elements, then next two elements, next two element, and you ensure that if the left side element is greater than right side element, if left hand side element is greater than right side element, then you simply swap. Then you simply swap. If it is greater, then you swap. If it is not greater, you don't swap. So what happened with this? What happened with this? In this way, the greater element will slowly go at the end of the array. So जिसको हम लोग कहते हैं bubble sort. So जब हम लोग कहते हैं water में, when the bubble is generated, the bubble will scroll up, the bubble will scroll up, and as bubble scroll up, then it will grow in a size. On the similar element, similar line, when you go from this end to this end, you'll find that the largest element comes out first. The largest element comes out first, and that is the reason the name is given as bubble sort. As I told you, you always remember why the name is given, so that automatically you can remember the algorithm behind it. Correct? So let us just get started. The bubble sort is like one of the easiest algorithm ever. You simply say that you want to compare these two elements, and if left hand side is greater, if left hand side is greater, then you want to sort, then you want to swap. रुको जरा कल के जैसा, let me just put two markers over there. This is like a left side element, let's say right side element, and you compare. So obviously I need to swap this. So 6 is greater than this. Then you continue further. Now you compare the next two element. Again you find that the 6 is greater than 2. 6 is greater than 2. So you find that 2 goes in place. 6 comes over here. Again you continue further. and 6 and 8. Now you find that the 6 is smaller than 8. 6 is smaller than 8, nothing much to be done. You continue further. 8 is greater than 3. As 8 is greater than 3, so 3 is over here, 8 is over here, and again you continue the process. Again you continue the process. You find that 8 is greater than 1. As 8 is greater than 1, your one pass is completed, and with your one pass completed, you must have observed that the highest element reach to the end. That is the reason I call it a bubble sort. कि जब ने शुरुआत किया था, you might have started with the smaller number, but as you reach to the end, you will take the greatest element to the end. That is the reason it was a bubble sort. But by the way, this is only sorted one element. Yes, it is like first pass or first iteration. Why not you repeat the story once again? Oh, you repeat the story once again, and again you start comparing. Again, 4 and 2, 4 and 2, you find that 4 is greater than 2. So 2 over here, 4 over here, and you continue further. 4 is smaller than 6, nothing much to be done. 6 is greater than 3. Yes, 6 is greater than 3. 3 over here, 6 over here, that is good. You continue further. 6 is greater than 1 as well. 6 is greater than 1 as well. So 1 over here, 6 over here. So done, it's over. And Ruko, you can always compare the next element as well. But even though you compare, you find that it is not really matching. Uh, the left hand element is still smaller, so nothing much to be done. So what do you find? The second highest element reach to its final destination. And again, you continue the process. Now you find that 2 is less than 4. That is good. But 4 is greater than 3. 4 is greater than 3. Go ahead. 3 over here. 4 over here. You done the swapping. You continue further. And then again, 4 is greater than 1. As 4 is greater than 1, again it need to be swapped. It is done. You compare the next, nothing much to be done. You compare the next, nothing much to be done. That is good. And now the third highest element reach to its final position. Or you continue the process once again. This is probably the three passes are done. Now the fourth pass. Now 2 and 3, you find that 2 is smaller, nothing much to do. But 3 is greater than 1. 3 is greater than 1. So you find you need to do the swapping, and then you continue the process once again. You continue the process once again. 3 and 4, oh, no swapping is required. 4 and 6, no swapping is required. 6 and 8, no swapping is required. That's it. And what you achieved is that the next element at its final position. Let us just go ahead, make it at the start. And again, you find that 2 is greater than 1. 2 is greater than 1. Do the swapping. This is done. This swapping is done. Next two, no swapping is needed, no swapping needed, no swapping needed, no swapping needed. That's it. Nothing much to be done, and it's over. It's over. The 2 is at the final position. Now there are no more two elements are left. There's only one element left. So there is nothing that you need to compare. So ultimately, for the array of 6 elements, you have done 5 passes, and in 5 passes you find that your whole array is in sorted order. I hope the algorithm is clear. Still, I will go through the algorithm quickly once again quickly, and it will be good if you could do a paperwork with me. वैसे bubble sort is like easiest sorting algorithm, I know, but still we will follow what the way we are doing. As I said that it will be great if you could do the paperwork along with me. You will be a bit more comfortable. And while doing paperwork, if you at all find that some questions are there, queries are there, please do ask. Let us begin with. Let us begin with what you are saying. You are saying that we want to compare two consecutive elements. So पहले ये दो compare करेंगे, फिर ये दो compare करेंगे, फिर ये दो compare करेंगे, फिर ये दो compare करेंगे, और फिर ये दो compare करेंगे. At any moment, if the left hand side element is greater than right side element, we will do the swapping. So let us begin. 6 and 4. Swapping is needed. I hope you are participating now. The swapping is needed. Yes. 6 is greater than 4. So I need to swap 6 with 4. Okay. Let's go ahead. Next. 6 2. 6 2. Again, you find that the 6 is greater. Left hand side element is greater than right hand side element. So again, go ahead, do the swapping once again. You continue further. 6, 8. 6, 8. Oh, sorry, 6 is smaller than 8. So no swapping is needed. 8, 3. 8, 3. Yes, 8 is greater than 3. So take 3 over here, 8 over there. 8, 1. 8, 1. Again, I find that. So it is over here, it is over here. This is done. So my first pass is completed. First pass is completed. I found the largest element at the end. And then you continue further, you repeat the story. You repeat the story, you start with, what is that? 4 and 2. अगेन पहले से वापस से एंड तक हम लोग सारे कंपेयर करेंगे. 4 and 2, 4 is greater than 2. Okay, that is good. 4 and 6, 4 and 6, sorry, no swapping is required. 6 and 3, 6 and 3, 6 is greater than 3, so please swap, that is good. Next, let's move further. 6 and 1, again 6 is greater than 1, so you again continue swapping it, done. And 6 and 8, again 6 and 8, no swapping is required, that's it. The second pass is completed and it's done. You continue further, you continue further, you start with this. What is next? 2 and 4, 2 and 4, 2 and 4, no swapping is needed. But now you find that 4 is greater than 3, 4 is greater than 3, yes, swapping required. You continue further. 4 and 1, 4 and 1, 4 is greater than 1, so again swapping is required. 4 and 6, no swapping needed. 6 and 8, no swapping needed. Again, the element reach to its highest, what that appropriate position. You compare it once again. 2, 3. 2 is not greater than 3. Okay, that is good. Next, but 3 is greater than 1. 3 is greater than 1. So let's take 1 over here. Let's take 3 over here. And then again you compare. 3, 4, no swapping needed. 4, 6, no swapping needed. 6, 8, no swapping needed. That's it. And the 3 reach to its position. You continue once again. 2, 1, 2, 1. The last pass. Yes, 1 is over here. 2 is over here. Done. And then you continue the process. 2, 3, 2, 3, no swapping needed. 3, 4, no swapping needed. 4, 6, no swapping needed. 6, 8, no swapping needed. So that's it. All is done and all elements are sorted. So your algorithm is like very simple. At any moment, we are just comparing two back-to-back elements. If you at all say that this element is J, if you say that this element is J, this element is probably J plus 1. So you are comparing jth element with j plus 1th element, and if you find that jth element is greater than j plus 1 element, if jth element is found to be greater than j plus 1 element, then you do the swapping. So how do we write a code basically? I guess writing code should be a very easy job. Let me simply say that for j is equal to 0, j is less than n minus 1. Please note, I said less than, I didn't say less than or equal to. And at the same time I said n minus 1 as well. So make a note of both of them. And then inside this, I want to check if a of j is greater than a of j plus 1. A of j is greater than a of j plus 1. Is it true? Yes, it is consecutive elements that we are comparing. And if it is greater, what is to be done? If jth element is greater than j plus 1 element, what we need to do? Yes, we need to simply swap the jth element with j plus 1th element. This is what the logic I guess we seen right now. But you understand that this was a logic for your one pass. This was a logic for one pass. And how many such passes I need to complete? This is a logic. This is a logic for one pass. How many such passes we need to conduct? Oh, n minus 1 passes that we need to conduct. And if you at all think of n minus 1 passes for I is equal to 0, I is less than n minus 1, I plus plus, please note the outer loop is only counting the passes. Outer loop, अगर आपने ठीक से note किया है, this I is not used in the inner loop. So it is only just to ensure that just to ensure that n minus 1 passes are done. Just to ensure that n minus 1 passes are done, and this part is actually conducting the pass. Is it so? Yes, it is so. Nothing much is there. Why not we go ahead? Why not we go ahead and we create a Maven project? नहीं Maven project नहीं, sorry. हम लोग जावा पढ़ रहे हैं ना. So new. Okay, core Java project. I create a Java project, and yes, we will continue on to the sorting. I hope आपका Eclipse ready है. Things you people are done, and if it is done, I can say finish. Done. Okay. Let me just go ahead, create new class, and obviously the name of a class is, let's say, sorting main. All right. Yeah. So this is good. We have like a main function, and we are trying to write a method. Public static void, let's say bubble sort. You can name bubble sort, and for the bubble sort you can pass the array to be sorted. Array to be sorted, the logic was pretty simple. For you can try to reiterate on over the array. J is equal to 0, j is less than length minus 1, j plus plus, and you are comparing if arr of j is greater than arr of j plus 1. So jth element with its next element, what is to be done? Oh, all I need to do is that I need to swap. As I hope yesterday I told you, it is really good idea to talk to yourself when you are typing a code, so that behind the scene you are also understanding what you're doing. I hope upload these tricks you people are trying. So error of j is equal to error of j plus 1, and then error of j plus 1 is equal to 10. Done. So this will take care of swapping. So the basic idea is done. It's not a problem. But this is, as I told you, this is for one pass. So what we are done in your one pass, that compare consecutive elements, and if the what is that left element is greater than right element, then swap. That's it. That is like a basically logic that we have used, but we want to say that we want to repeat this for n minus 1 passes. And how do you repeat this for n minus 1 passes? Is I was trying that for I is equal to 0, I is less than, again ar dot length minus 1, I plus plus. So we are repeating the whole process for for n minus 1 times. We are repeating the whole process for n minus 1 per time. So I'm simply saying that let's conduct, or let's say execute, whatever, execute n minus 1 passes. That's it. So outer loop is only for the comparison. Sorry. Let us go ahead. I want to create an array. I guess yesterday also I created an array, but that was in like a yesterday's project. So I thought of creating an array route right now once again. And the array is, let's say we have got 6, we have got 4, we have got 2, we have got 8, we have got 3, we have got 1. That is good. And system.println arrays. Sorry. Arrays dot sort, and arrays dot sort. Sorry, arrays dot to string. Using arrays dot to string, I can print this array. Okay, that is good. But this was like before sorting. This was definitely before sorting. How do I print it after sorting? I'll say that same way. I can also think of printing it after the sorting. Meanwhile, I want to call the code selection sort. नहीं selection नहीं, क्या अभी हम लोग bubble sort कर रहे हैं ना? Okay, So bubble sort, you pass the array. It's done. So will it work? I believe so. Let's check. Oh, is it working? Oh, look like. Yes, the things are going well. I guess there is no trouble with this. Chalo, I guess you people also want to try it. Please go ahead and try it. Don't only try it. Also, you have any questions, please do ask. Good. So we are able to do that. And as I said that our flow is very simple. We'll first get the philosophy. We will try the algorithm on paper twice at least. And then if you still have any doubt, you can always ask. And if no, then we can move on. We'll write a code. As code is written, probably we want to also talk about the efficiency. Oh yes, and talk about the efficiency and talk about the time complexity. And so let's understand that. By the way, you must have understood that how many passes are done? Oh, there are probably n minus 1 passes. So you find that when I is equal to 0, when I was equal to 0, at that time, how many comparisons are done? Internally, ये जो आपका loop है, यहाँ पर how many comparisons are done in this loop? Yes, 5 comparisons. So you have done total 5 comparisons, or let's say inner loop 5 iteration. So I'm talking about like inner loop, jth loop is a 5 iteration. But if you have seen it very carefully, when I is equal to 1, or when I is equal to 2, or when let's say I is equal to 3, I is equal to 4, all the times there were only 5 iterations, isn't it? All the time we went through, all the time we went through the whole array, and every time we are doing 5 iterations each. And if you are doing 5 iterations each, the total number of iterations, if you have done addition, I guess that comes out to be 25 iterations. Okay, that is pretty simple. However, however, let's just go ahead and what I can say, I want to look for what is exactly the time complexity. A number of iterations. Can you tell me now the inner loop total number of iterations? Inner loop total number of iterations right now for 5, sorry, for 6 elements, we have seen that there are total 25 iterations. तो ये तो हम लोगों ने on paper किया था. I'm saying that in general formula, only in general formula, you find that n minus 1 passes, n minus 1 passes, and n minus 1 comparisons, n minus 1 comparisons for each pass. N minus 1 passes and n minus 1 comparisons for each pass. And with this, you can always say that it is n minus 1 into n minus 1 iterations. If n minus 1 into n minus 1 iterations, I say that the time required will be proportional to number of iterations. Just go ahead, solve it, n square minus 2n plus 1. I hope this is correct. And if you recall the theory of approximation that we have seen earlier, all lower order terms can be neglected. As you neglect all no lower order terms, you find that it is like n square, and then the time complexity can be obviously said to be O n square. I hope this is pretty simple, pretty straightforward. The things are with you. So if you've seen whatever implementation that we have done right now, selection sort is faster or bubble sort is faster? Whatever implementation that we have done right now, the selection sort is faster or bubble sort is faster? So you always find that no, not really, not really. अगर आप लोग कल का प्रोग्राम ठीक से देखते हो, there were only 15 iterations were there. Have a look at this. There were inner loop was repeated only for 15 times, and for the same array For the same array, today it is repeated for 25 times. 25 times. What I want to tell you is that as far as running time is concerned, as far as number of milliseconds or microseconds are concerned, you will always find that the selection sort in this implementation, I'm saying that with this implementation, selection sort will go faster than the bubble sort. But as far as time complexity is concerned, you find that time complexity is still remaining same. So ऐसा क्यों हो रहा है? Because time complexity is an approximate measure of the time. It is a time complexity is an approximate measure of the time. It is not the exact measure. So in this particular case, I can say that with the current implementation, the selection sort can go faster, or the selection sort will have the lesser running time, will have the lesser running time as compared to the bubble sort. The actual time wise, you will always find that, I repeat, मैं बार बार एक word use कर रहा हूँ, with this implementation. So with this implementation, you always find that the selection sort is going faster as compared to the bubble sort, because the number of iterations are reduced there. However, the next question, so sir, can we really improve the bubble sort? Can we really improve the bubble sort? And my answer is yes. There likely chances are that you can always improve the bubble sort. And what do you mean by improve the bubble sort? I'll just say that I'm repeating algorithm once again. And when I'm repeating algorithm once again, I may not do all passes, but just pay attention and try to appreciate that whatever efforts that we have taken at this moment, give me a minute. Yes, again we are comparing two consecutive elements. As you are comparing two consecutive elements in a first pass, you find that 6 is greater than 4. Yes, we have done swapping. Let us continue further. No swapping is needed. Sorry, again 6 is greater than 2. So swapping. In this case, no swapping is needed. You continue further. 8 is greater than 3. You do the swapping. And then again you continue further. 8 is greater than 1. Again you do the swapping. And now you realize that, see it carefully, you understand it very well, that the largest element is reached to the end. If you know that the largest element reached to the end, to be frank, in a next pass, there is no need to compare the further one. I hope you are getting my point. अगर आपको already पता है 8 is already reached to the end and 8 is already the greatest element, so जब आप लोग second pass के लिए जा रहे हो, वापस से 8 के साथ compare करने की कोई आवश्यकता नहीं है. Even though the code that we had written, it was still doing the same, वो बात अलग है, but it was always possible, I'm trying to tell you. Now again you find that 4 and 2, so 4 is greater, so you swap, no swapping is required. 6 is greater than 3, a 6 is greater than 3, okay, that is good. And again you continue, 6 is greater than 1, okay, that is all right. Now see it carefully. Now you know it very well, this element has reached to its final position. There is no need that you really compare this. Why you really compare this? क्योंकि फर्स्ट पास में लार्जेस्ट एलिमेंट ऑलरेडी एंड में गया होगा. वैसे भी अगर आप लोग इसको कंपेयर करते हो, आपने नोट किया था, वैसे भी स्वैपिंग नहीं होने वाला है. वैसे भी स्वैपिंग नहीं होने वाला है. इट वाज नॉट एट ऑल नीडेड. करेक्ट. एंड यू विल सी द सिग्निफिकेंट डिफरेंस अगर आप लोग लास्ट वाला पास नहीं करते हो. हैव अ लुक एट दिस. सो in a first pass, when probably I is equal to 0, I'm saying that the number of iterations, ये जो आपका inner loop है, the inner loop के जो iterations है, when I is equal to 0, yes, you need 5 iterations. But when I is equal to 1, in a second pass, you actually need 4 iteration. Fifth वाले iteration की जरूरत ही नहीं है. Fifth वाले iteration की जरूरत ही नहीं है. And you continue it further. You again understand that a 2 is less than 4, nothing much to be done. But now 4 is greater than 3, you do the swapping. Again you compare, 4 is greater than 1, you again do the swapping, correct? And then, to be frank, again the next comparison is not at all needed. Next comparison not at all needed. In this pass, 1, 2 and 3, the three comparisons are probably more than sufficient. And then you continue further, you can always see that there are two comparisons, and the last one, there is like only one comparison is also sufficient. There is absolutely no need that every time you want to go till the last last element, because those elements are already the largest elements and they are already, reached to their final position. So unnecessary comparison that we had done it in an earlier code was not really necessary. Then you ask the question, so sir, how we can improve on this, or how we can improve on this? That can be done like quite easily. That can be done quite easily. What you are simply saying, yes, absolutely. What you are simply saying, जब last time यहाँ पर आपने क्या किया था, j is, have a look at this, j j is less than n minus 1. Please make a note, j is less than n minus 1. J is less than n minus 1. All I need is that I need to consider one more factor into that, minus I. Minus I, you understand that in the first pass, I is equal to 0. I is equal to 0, so it will go up to n minus 1. In a second pass, I is equal to 1. So it will go for n minus 1 minus 1. Means it will go up to n minus 2 only. In the next pass, I will be equal to 2. I will be equal to 2. So this will go basically till n minus 3 only. And then when n is equal to 3, it will go to the n minus 4 only. That's it. Nothing much you need to do it. So all changes that you need to do over here, इस पूरे कोड में अगर आपको कुछ चेंज करना है तो सिर्फ इतना एक पार्ट चेंज करना है, rest entire code remains same. But what is the advantage? What is the advantage? The advantage is that now you compare the number of iterations. Can you compare the number of iterations now? The number of iterations right now, as you seen, the first one, they're like a n minus 1 iterations. And the second pass, n minus 2 iterations. And this way, the last pass, like a 1 iteration. I believe this is exactly same as of selection sort. You find that the total आप लोगों ने करके देखा होगा, I'm very sure. The total जो आप लोगों ने किया था, I guess again it comes out to be 15. Oh, that is good. And then I can simply say that the time complexity, a time complexity will be same as, a same as selection sort. Even the running time is same as selection sort. The time complexity is same as selection sort. Even the running time is same as selection sort. That is what all you can do. By the way, ये जो था, I refer this as something called as a improved bubble sort. This is improved not in time complexity. Time complexity इसका भी O n square है, इसका भी O n square है. But as far as running time is concerned, this is bit better as compared to the other one, earlier one. Okay, that is good. And if you understand this, you can always go there. You can always copy paste this, and same logic. All I'm saying is that I need to just do one change, minus I into that, and I can say that this is nothing but improved bubble sort. All right. And if you, instead of bubble sort, if you try to call kind of improved bubble sort, am I going to get the same result? I believe yes, you should be able to get the same result. Why don't you run it once again? And you find that yes, your array is still sorted. I hope ये कोड मुझको शेयर करने की जरूरत नहीं. It is hardly one change is to be done. Please go ahead and do it. Please go ahead and do it. So it is hardly minus i's to be added as far as code is concerned. तो आप लोगों ने नोट किया, एक दो कैरेक्टर्स इधर उधर चेंज करने से टाइम कॉम्प्लेक्सिटी चेंज नहीं हुआ है, बट व्हाट इज चेंज, द रनिंग टाइम इज इंप्रूव्ड अ लॉट. Running time is improved a lot, and that is a good thing. And now, if this is clear, I want to still think of optimizing it even one more step ahead. तो सर इसका भी ऑप्टिमाइजेशन हो सकता है. Yes, this can be still optimized. This can be still optimized. Consider a case. Consider a case that your array is already sorted. What if your array is already sorted? What if your array is already sorted? With the logic that we have written right now, the logic that we have written right now, we are still doing 15 passes. Oh, we are still doing 15 passes. Even though your array is already sorted, we are still checking, पहले pass में 5 comparison, second pass 4 comparison, next pass 3 comparisons. तो वैसे भी हम लोग ये कर ही रहे हैं. तो सर, is there any way that we can do it better? हम लोग क्या कर रहे हैं बबल सॉर्ट में? हम लोग बेसिकली क्या कर रहे हैं बबल सॉर्ट में? हम लोग कंसेक्यूटिव एलिमेंट चेक कर रहे हैं. And at any place, if the lower element is greater than lower element is greater than the higher element, the upper element, we say that we want to swap them. We want to swap them. So ultimately, suppose that if your array is already sorted, have a look at this. If your array is already sorted, something like this. Wait for a minute. I don't need this now. I'm not bothered about this. And let's consider that your array is already sorted. 1, 2, 3, 4, 5, 6. Yes, done. So I'm saying that in this particular case, if you follow this algorithm, what will happen? In a first pass, you find that 1, 2, no swapping needed. 2, 3, no swapping needed. 3, 4, no swapping needed. 4, 6, no swapping needed. And 6, 8, no swapping needed. So what I'm saying is that at any pass, when you realize that, at any pass, when you realize that no swapping is needed, what does it mean? What does it mean? It simply means that your array is already sorted. And if you at all say that your array is already sorted, my question is very simple. Why to go for a next pass? I'm just making a simple logic. See, what I'm saying is that if array is already sorted, you compare the consecutive element. You say that 1 is smaller than 2, no swap needed. 2 is less than 3, no swap needed. 3 is less than 4, no swap needed. 4 is less than 6, no swap is needed. 6 is less than 8, no swap is needed. It only means that all elements are already arranged, already organized in one particular way. And if all elements are organized in ascending order, it is very simple. There is no need to go for a next pass. Why are you wasting your time? Okay, I understand that. But the question is that how do I keep a track of whether any swap is done or not? How do I keep a track of any swap is done or not? So what I'm saying is that why don't you declare a flag? Why don't you declare a flag? So I'm saying that you can have some flag declared. You can have some flag declared, and into the flag, have a look at this. You can have something, let's say swap flag. So we can write swap flag is equal to false. Swap flag is equal to false. At any moment, at any moment, if at any moment, if there is a swapping, you just go ahead and say that the swapping is done. So I'm making swap flag is equal to true. Swap flag is equal to true. And once it is done, now at the end of the pass, see, before the pass, we said the swap flag is equal to false. During a pass, if anywhere the swap flag, whenever swapping is done, I simply say swap flag is equal to true. At the end, if I find that the swap flag, the swap flag is still false, swap flag is still false. What is the meaning of this? In this particular case, I also understand that there is not a single swap done in an earlier pass. And if it is false, so there is no need of repeating even the next iteration. I can directly say break and I can come out. I can directly say break and I can come out. So what is this? I can say that this is not only the improved bubble sort, I can say that this is, let's say, more improved bubble sort. So like an improvement at one stage ahead. But what you achieved into this? What you achieved into this? Number of iterations आपके कम होंगे क्या? Number of iterations तब कम होंगे if your array is already sorted. If your array is already sorted, then number of iterations are reduced. Can you tell me, if array is already sorted, total number of iterations that the inner loop see, how many are there? Only 5 iterations. That's it. Inner loop, एक बार तो आपको पूरे iterations करने ही पड़ेंगे. एक बार तो पूरे iterations करने ही पड़ेंगे if your array is already sorted. And this is nothing but, you can consider it as a best case. This is nothing but a best case. Best case, what is that? Array. What is the best case that we have got? The array already sorted. And if array is already sorted, what do we see? The inner loop inner loop is repeated, or other repeated नहीं कहना चाहिए, repeated executed only once, only once. So number of iterations will be simply n minus 1, and obviously the time required is proportional to n minus 1. N is large enough, you can ignore minus 1, and you can simply say that time complexity is O of n. What we are discussing over here is a best case of selection sort, sorry, bubble sort. Please understand that this is possible in this implementation. अगर आप लोग ये वाला implementation कर रहे हो, then what is the best case? Then there is no best case. Even in the best case, you are still going with all the iterations. It will still O(n) square. So many times, people keep come down and ask me, so what is the best case of bubble sort? I always say that it depends on your implementation. It depends on your implementation. It is not like that कि you can say that नहीं नहीं ये faster है वो faster, बिल्कुल नहीं. It depends on your implementation. आपका implementation क्या है उसके ऊपर चीजें डिपेंड करेगी. अगर आपका ये implementation है, the best case is still O(n) square. लेकिन अगर आपका ये वाला implementation है, अगर आपने flag use किया है, then in that case I can say that in best case there is only one pass will be executed. Only one pass is executed, the time complexity will be O of n. So whenever the question is asked in interview, you need to answer, well, not a by-hearted answer, right? So chalo sir, implement करके देखते हैं. Will it take time or not at all? This is like a very simple one. As I said that, I'll just copy paste this once again. And I call this as more improved bubble sort. In a more improved bubble sort, what I'm looking for a Boolean variable, and I'm calling it as a swap flag, and this swap flag is equal to false. Okay, that is good. You continue further. If at all swapping is needed, you just add a line swap flag is equal to true, and at the end of the iteration, please note at the end of the iteration, जो inner loop आपका खत्म हो जाएगा, when your inner loop is completed, at that time, at the end of the inner loop, you check if it is not swapped. If it is not swapped, simply say break and you come out of the loop. And this will ensure that if array is already sorted, you will be having, next passes will be actually skipped. Next passes will be actually skipped. So will it work? To be frank, in this case, उसका कुछ ज्यादा फर्क नहीं पड़ेगा क्योंकि हमारा array already sorted नहीं है. I'm just calling it for your comfort so that you understand this and you get the result. Obviously, the result is same. I hope this is clear, and what is happening? Please go ahead and try it. Any questions are there? Do ask. Good. So we talked about bubble sort. We talked about improved bubble sort. We talked about more improved bubble sort, and we also seen that with the more improved bubble sort, we can handle a best case in a bubble sort. To be frank, तो सर ऐसे ही mechanism हम लोग selection sort में नहीं कर सकते थे क्या? Unfortunately not. Selection sort, you can just go back, you can just do paperwork, and you realize that keeping a flag kind of technique, ऐसा कुछ नहीं है कि आप लोग सब जगह पे एक ही टेक्निक यूज करो. It is not possible. And if this is clear, now we should be going ahead and we should start discussing on to something called as a insertion sort. So should we move on insertion sort? Anywhere that you find that the things are going bit fast, please let me know. Let me know in time. All right. I'll go as per your response. I'll go as per your response. If you responded, you say that no, sir, we are still copy pasting your code. It takes little time. So let me know. That is still fine. But if it is not, I'm asking you again and again. Please ask the questions, if any. If you are not asking the question, then I'm assuming that okay, you are getting the things. So feel free to ask wherever you have doubt. And now we will go on to the next algorithm, insertion sort. Now this algorithm is bit tricky. Bit tricky in the sense not very common that students learn that. And that is the reason we want to see it one by one. Ashraf saying that please summarize important point to remember for the algorithm at the end. Ashraf, in my opinion, there is nothing important as far as this such a basic algorithms are concerned. Like your algorithms are pretty simple. The time complexity is that we are calculating. So only thing that you need to remember is basically the philosophy of the algorithm that we started at the start, that why it is called a bubble sort, and at the end, what is the time complexity of that. So किसी भी algorithm में इससे ज्यादा special कुछ नहीं होता. Or algorithm is algorithm. So algorithm में more important, less important. I personally do not see anything that is like more important. अब I variable लेना है, J variable लेना है, temp variable लेना है, swap variable लेना है. That's it. Now you cannot keep discussing that this line is more important, this line is less important. हाँ, wherever ऐसे जब algorithm आएंगे, जब उतने बड़े algorithm आएंगे, definitely we can discuss that as well. But I believe these algorithms are pretty simple. If you need anything explicitly to be asked, feel free, go ahead. We will discuss that. Okay, I'm just starting with and talking about insertion sort. And teaching insertion sort is not what I say. The teaching insertion sort is something very easy, provided you know in advance what is insertion. So I'll just like to keep insertion sort aside for some time. Insertion sort aside for some time, and I want to focus on something called as a insertion technique. I repeat once again, I want to focus on something called as a insertion technique. So what is the insertion technique? Let us just go ahead. Let us first understand what is insertion technique. Once you understand insertion technique, then we will discuss the insertion sort. I repeat once again, I'm not teaching you the insertion sort. I'm only talking about the insertion technique first. What is insertion technique? Let us talk about that. Once you understood insertion technique, then let me know. Then we will move and we will discuss about insertion sort as such. I hope you are ready. So let's say that this is my array at the initially. This is my array initially, and let us get started. Now tell me, is this array is sorted? Is this array is sorted? No. Is this array is almost sorted? Is this array is almost sorted? See it very carefully. You'll find that only one element is unsorted. अगर आप लोग इस एक एलिमेंट को बाजू में निकालते हो, you find that your rest of the array is well sorted. Except to rest of the array is almost sorted, right? And this is a technique that I am trying to focus. मैं फिर से बता रहा हूँ, मैं इंसर्शन सॉर्ट नहीं पढ़ा रहा हूँ, मैं इंसर्शन टेक्निक पढ़ा रहा हूँ. इफ यू कुड अंडरस्टैंड इंसर्शन टेक्निक, learning insertion sort is matter of 2 minutes. So please focus on to that. So what the logic is, a logic is very simple. The element which is not sorted, sorry, the element which is not sorted, you take it out. You take it out, you take it in some temporary variable. And once you take in a temporary variable, you start comparing it with all previous elements. Now you start comparing with the previous element, you start comparing it with 8. You compared with 8, you realize that 8 is greater than 2. You please shift it. I do not say swap it. I said shift it. Shift it to the next position. You compare it with the previous element. You compare with previous element. Again, you find that 6 is greater than 2. 6 is greater than 2. Shift 6 to the next position. Again, you continue further. You find that 4 is greater than 2. 4 is greater than 2. Again, you shift it. You continue further. You find that 3 is still greater than 2. 3 is greater than 2. You shift that. And again, you compare with 1. 1 is a 1 is not greater than 2. If 1 is not greater than 2, what exactly it means? It only means that this is the ideal position for the 2. So जहां कहीं पर भी आप लोग 1 है, उसके बाद वाली लोकेशन पे, उसके नेक्स्ट लोकेशन के ऊपर you want to put your 2, and this is nothing but I call it the insertion technique. I hope you got that. I'll just go through it once again. I'll go through it once again. Please note, this technique is to be followed only when your last element is unsorted. If your whole array is unsorted, this technique is of no use. This technique is of no use. So I'm just going ahead and I'm saying that let us take a temporary variable. This is a temporary variable. I just taken this, and you start comparing it with all previous elements. You start comparing it with all previous elements. You find that this element, let's say हम लोग इसको j कहते हैं. So jth element is greater than 2, greater than 10. So shift this. You compare with the previous one. 6 is greater than 2, you shift it. Again you go ahead. 4 is greater than 2, you shift this. Again you find 3 is greater than 2, shift this. Finally you go over here and you find that 1 is not greater than 2, 1 is less than 2. If 1 is less than 2, what I'm saying, I simply say that this position is ideal position. This position is kind of ideal position for 2, that is after 1. Is this clear? Wait, I'll take up one more example. I'll take up one more example. This is like one example I already repeated twice. I'll take up one more example. With one more example, see it carefully. Now my example is a bit different. Example is a bit different, and I would love to draw even the indices there. I'll just draw some of the indices there. This is index 0, index 1, index 2, index 3, index 4, and index 5. This can be even said like index -1. Correct? So this is kind of array that I have got. Again, I believe that this array is still almost sorted. If the array is almost sorted, what to do? If the array is almost sorted, what to do? You take out this element. You take out this element, and as you take out this element, you start comparing with all elements before that. All elements before that, you find that 8 is greater than 1, shift it. Good. 6 is greater than 1, shift this. 4 is greater than 1, again shift this. 3 is also greater than 1, again shift this. 2 is also greater than 1, again shift it. But now you find that there is no element to compare before that. Now there is no element to compare before that. It also means that this element is probably the smallest element, and I should insert that element after this. After this is after -1. So in short, I should be putting it at the 0th location. I'll repeat it once again. This is where things are, and I'm saying that you start comparing. You take the last element out. This element is unsorted. If this element is unsorted, please pay attention. If this element is unsorted, you take this element out. Taken this element out, you start comparing with all elements before that. All elements before that. So you start comparing with this. What is that? 8. 8 is greater than 1. So shift it to the next location. 6 is greater than, oh sorry, I can say z minus minus. 6 is greater than 1, you shift this. You continue further. 4 is greater than 1, again you shift this. 3 is also greater than 1, again you shift this. 2 is also greater than 1, again you shift this. Please note, again if you are saying minus minus, again if you are saying minus minus, you are going with like a -1. Now j becomes actually -1. Now what you need to do, I said that in this case, अब comparison मत करना. अगर आप लोग comparison करते हो, you will get array index out of bound exception. I do not need a comparison to be done over here, but in this case, I can say that 1 can be inserted at this location. So this seems to be a right position. So after -1 is right position to be added. Is this clear? And if this is clear, how you convert into the code? Oh, that is something that I need to worry about. The insertion technique, how I can convert into the code. Oh, how I can convert into code? I'll just go ahead. मैं वापस से इंसर्शन सॉर्ट नहीं पढ़ा रहा हूं, मैं सिर्फ इंसर्शन बता रहा हूं. Void, let's say insertion. I'm just writing only insertion. Go ahead. And then I'm saying that I'm assuming that the last element in this particular case, I said that last element is nothing but क्या कर रहे थे हम लोग? It is an important element or like unsorted element. The last element is unsorted element. I want to take it out. So how do you do that? So I can simply say temp is equal to ARR of, how do I get the last element? I believe it is quite simple. ARR dot length minus 1. So this is nothing but I'm getting the last element. Then what I want to do, I want to compare with all elements before that. Oh, all elements before that, you continue further. J is equal to, if from where you started with something called as ARR dot length minus 2, correct? You started with ARR dot length minus 2, a minus 1 तो वैसे भी last element है, उसके पहले वाला element. And then J is greater than equal to 0, J minus minus. So what you are doing is that you are continuing comparing with all elements before that, all elements before that. And then each time, wait for a minute, each time you find that jth element, have a look at this. Each time, if the first condition is true, then and only then I'm going on a second condition. If you find that AR of J is greater than 10, if you find that ARR of J is greater than 10, then what do you want to do? Oh, I want to just shift it. So ARR of J plus 1 is equal to ARR of J. This is what you do the shifting. Jth element, you want to put it in like a J plus 1th element. Jth element, you want to put like a J plus 1 element. That is what all we are doing. Okay, good. And this way, see now your condition will be false in either one case. Either a case where ARR of J is not greater than 10. Either a case where ARR of J is not greater than 10. Possibility number 1, and possibility number 2 where J becomes kind of minus 1. Please note there are two possibilities just above we have discussed. So there are two possibilities. Either you find a number which is less than 2, possibility number 1, or your J reach to something, let's say minus 1. You reach to the minus 1 index. Either case, a logical AND है. If any one condition is false, you are going to come out. But if you come out, what do you want to do? I want to just add the element onto the next position. I just want to add the element onto the next position. I just want to add the element onto the next position. So what exactly? It is very simple. All I want to say is that ARR of J plus 1 is equal to 10. This is nothing but a insertion technique. I hope you got the point. I'm just quickly going through the code once again. Please pay attention. Please pay attention. So what I'm saying is that I was considering in a scenario where the last element is unsorted. In a first example over here, I said that यहाँ पर 2 unsorted था. I repeat once again, do not ask me the question on a sorting. जो अभी मैं पढ़ा रहा हूँ, let us first focus on that. First understand that, then I will teach you insertion sort. And once you understand insertion sort, if any questions are pending, then ask it. बहुत आगे वाला मत सोचो, ज्यादा कंफ्यूज हो जाओगे. Go step by step, right? Wait, hold on. मैंने कहा ना अभी जो मैं पढ़ा रहा हूँ, it will be really good if you focus onto that. What is the focus? अभी मैं insertion technique पढ़ा रहा हूँ. You learn insertion technique. Any question regarding insertion technique, do ask. And then how insertion is related to insertion sort? Oh, that is a different question that I will come down later, right? मैं शायद मैंने कल भी आपको बताया था. डेटा स्ट्रक्चर में सबसे बड़ा प्रॉब्लम ये है, distractions is like a biggest problem. So you start teaching one topic, students are thinking of the next, and then by the time you reach to the next, they have not understood the basic topic, and then they are confused. So this is very complicated. I always suggest, I always recommend, let the topic be completed, and then you have any questions, yes, you can definitely ask. Or if you have a question related to what is going on, do ask at that moment. करेक्ट? आगे वाला मत पूछो, होल्ड ऑन, हैव पेशेंस। चलो हम लोग आगे जाते हैं। हम लोग कहां पर थे? तो मैं आपको यहाँ पर बता रहा था, इन अ फर्स्ट एग्जाम्पल, अरे क्या चल क्या रहा है? In a first example, I said that this element, something is going wrong with this. Yeah, no problem. What happened to the key? So in the first one, what you say is that, this element is greater. This element, sorry, this element is unsorted. You take out this particular element and you start comparing with all elements before that. You start comparing with all elements before that. Finally, you reach to the element which was smaller than that. Moment you find the element which was smaller than that, you just inserted the element after this, like a first pass. And the second one, in the second case, I said that I tried to find out that one itself, the smallest element itself was unsorted. वो at the end था, I just go back, I compared with all element before that, I didn't find a single element. Finally, I reached to the last index, like -1, last index meaning even before last index, -1, and then I found that okay, there is nothing to compare. So we added an element after that. What we have done in a code? In a code, I just started with ARR dot length -1. So this was nothing but my last element that I have considered, not a problem. Then you start comparing with all elements before that. Before that matlab length -2 se leke j is greater than or equal to 0, and every time I'm doing j minus minus. However, by the you want to repeat this full loop. If ARR of j is greater than 10, then jth element I want to shift it to j plus 1. Jth element I want to shift it to j plus 1, and this will continue. This will continue till what? In two cases. Either you find the element, which is less than 10, and if you find the element less than 10, you just come out of the loop and you try to add the temp, the element ahead of this. This is like a one possibility. The second possibility I'm saying, if there is no element smaller than 10, I simply say j is greater than or equal to 0, or condition is, if this condition is false, if at all this condition is false, what will happen? Oh, nothing much. Then in that case, probably j is equal to -1, and again you come out, and you see that oh, the elements you are trying to add at j plus 1 is equal to 10. Is this part is clear? Is this code is clear to everyone? Right. If this code is clear, it means that you people have understood well. What is insertion technique. And now if I understood insertion technique, then my next question is that, sir, वो insertion technique ठीक है कि when your only one element is unsorted, you are saying that it is very easy. But what if my entire array is unsorted? I do not know. Deepak is having question. Why j is equal to ARR dot length? I guess Deepak, I told you that we want to take one element out. Deepak, please pay attention. This is for you. You want to take one element out. ये जो आपका last element था, it was of length -1, isn't it? It was like a n minus one location. क्योंकि आपका array का indexing n-1 तक ही होता है. And now I want to compare all elements after that. If you are comparing all elements after that, then I guess it is n-2, isn't it? Deepak, is that clear? If this is n-1, obviously this has to be n-2, right? Sandeep, what do you want me to repeat? Last part. Which last part here? You're talking about a code? You're talking about algorithm? Code. No problem. Be specific. It will be really good. Instead like we wasting time. Going ahead. So I'm saying that I want to take here I'm assuming that I'm trying to tell you the insertion technique. With the insertion technique, what I'm saying is that if last element is unsorted, I want to put it in its right position. That is the idea. And if that is the idea, I do begin from this saying that temp is equal to ARR of n minus 1. N minus 1 क्यों? क्योंकि वो last element है. So I simply said length minus 1, which is the last element. I taken it in a temporary variable. I taken a temporary variable. I want to compare all elements before that. All element before that. अगर आपका लास्ट एलिमेंट n माइनस वन पे होता है, कॉमन सेंस आपका सेकेंड लास्ट एलिमेंट n माइनस टू पे होगा. सो फ्रॉम देयर j is greater than equal to 0, condition is true, then j minus minus. So I'm just making a loop going in a backward direction. Loop going in a backward direction, I'm checking j is greater than 0 at the same time if that zth element is greater than 10. If that zth element is greater than 10, then what I need to do? I need to just shift that zth element. I need to just shift that zth element to the next location. And next location, z plus 1th location. So zth element, I want to shift it to the next location. Zth element, I want to shift it to the next location. Zth element, I want to shift it to the next location. This is what all I need to do. Ultimately, ये loop false कब होगा? There are two possibilities. दोनों possibilities के लिए दो अलग अलग डायग्राम मैंने आपको दिखाए थे. एक possibility that you are saying that this element is this element is unsorted, you're taken it out. You started comparing with all elements and you found a variable or you found an element which is smaller than that. When you say that this element is smaller than that, you are also saying that this condition is false. And if this condition is false, what do you want to do? Obviously, you want to come out of the loop and simply say error of j plus 1 is equal to 10. तो 1 के आगे वाला जो लोकेशन है वहां पर मुझको 2 ऐड करना है. This is what all we need to do. We have done that. But the second case also I told you कि what if the 1 itself is unsorted? 1 itself is unsorted. You taken out 1. You taken out 1. You compare with all elements previously. As you compare with all elements previously, you do not find any element which is smaller than that. Ultimately, j reach to the minus 1. If j reach to the minus 1, j reach to the minus 1, I want to add the element after that. So again, I'm just going back and I'm saying that in this particular case, your j is greater than equal to 0, the condition is false, you come out of the loop because j becomes minus 1, and then AR of minus 1 plus 1, that is 0, temp is added. Is that clear now? Done. No problem. Now we will go ahead. And we will see what is the insertion sort then. मैंने कहा ना मैं अभी तक आपको इंसर्शन सॉर्ट नहीं पढ़ा रहा था. Now let me focus on insertion sort. And now please pay attention. Now it's insertion sort. If you are worrying about insertion sort, I said that now at this moment, focus, listen carefully. Do not focus onto the whole array. You just focus on an array of 2 elements only. Let us hope that my array is only of 2 elements. If I say that array is of 2 elements, which is the last element in this case? If I say that array is of 2 elements, which is the last element? Yes, last element in this case is 4. I simply say that you consider this as your last element, and if this is your last element, you start comparing it with all elements before that. What I said, if this is the last element, you start comparing it with all elements before that. So what I'm saying is that you consider that your array is now limited. Consider that your array is limited and your array is of only 2 elements. If your array is only of 2 elements, again you sorted हो भी सकता है नहीं भी हो सकता, I don't know. So you start comparing that ith element is the last element. You take out that element and you start comparing with all element after that. Hey, what I see that 6 is greater than 4. If 6 is greater than 4, shift 6 and then again you say j minus minus. As you say j minus minus, hey, what happened? J minus minus, that j is greater than or equal to 0, this condition is false, if this condition is false, you come out of the loop and then you try to insert this element after this. That's it, it's over. But this was an array of two elements. Wait for a minute, wait for a minute, and now you continue further. What do you continue further? Now you consider that your array is not of two elements. Now you consider that your array is of three elements. Now you consider that arrays of three elements. Please note that the earlier array is already sorted. If earlier array is already sorted, now again I'm saying you consider I is equal to 2 now. You consider I is equal to 2 now, and again you start comparing with all elements before that. How do you start comparing all elements before that? Let us again take it over here. Let us take this element out. Let us take ith element out. You compare with. I realize that 6 is greater than 2. Shift it. 4 is. Then compare with 4. Compare with 4. 4 is also greater than 2. Shift. Again you go out. Now you find that there is no element to compare. Put 2 over here. That's it. And this is nothing but my array is once again sorted. Now the array of three element is sorted. Array of three element is sorted. Sir, अब आगे क्या करना है? कुछ नहीं. Repeat the procedure. Why don't now you consider that you have got array of four elements. Now go ahead. Consider you got array of four elements. You got array of four element. The last element, the unsorted element. Let's say I is equal to 3. You take out the element. You take out the element in a temporary variable. You take out the element in a temporary variable and you start comparing all elements before that. You start comparing all elements before that. You realize that the 6 itself is smaller than 8. 8, if 6 is itself is smaller than 8, what is to be done? What is to be done? I want to add the element after that. Oh, you go ahead, you add the element after that, like 6, 8. So nothing much to be done. So you find that now this is already sorted. You continue further. You continue further. Now you consider the array is of 5 elements. You consider your array is of 5 elements, not 4 elements. Your array is of 5 elements. And the last element in this particular case, I can say I is equal to 4 now. Now you again continue and you compare with all elements before that. So temporary variable, you take it out. You start comparing. I found that, oh, 8 is greater than 3, shift it. 6 is greater than 3, shift it. 4 is greater than 3, shift it. 2 is not greater than 3. What is to be done? Very simple. Put 3 after 2. Put 3 after 2. And again, this much array of 5 elements is sorted. Last pass. Last pass, you consider you have got an array of 6 elements. You consider array is of 6 element. The sixth element is, let's say, 1. So at a time, we are not looking at the whole array at all. We are not looking at the whole array at all. You take it in a temporary variable where it was like I is equal to 5, and you start comparing with all elements before that. You compare with 8, 8 is greater. You compare with 6, 6 is greater. You compare with 4, 4 is greater. You compare with 3, 3 is greater. You compare with 2, 2 is greater. And then you reach to the -1. There is no element to compare. Just put this over here. And that's it. This is what all you call it the insertion sort. So what is the insertion sort? The insertion sort is very simple. You start from I is equal to 2, sorry, I is equal to 1 till I is equal to 5. Consider every time the ith element is the last element. Ith element is last element. Compare with all element previous to that and follow the insertion technique on that. You call it as the insertion sort. You call it the insertion sort. Don't worry. If it is not clear, I'm repeating it once again. I'm going ahead. I'm repeating it once again. That is the reason I was saying that please focus on insertion technique first. Do not worry about the sorting technique later. क्योंकि अगर आपको insertion समझ में आ गया है, now you are just, what you are doing? You are applying insertion 5 times. First with the array of 2, then with the array of 3, then with the array of 4, then with the array of 5, then with the array of 6. That's it. Nothing new that you are applying over here. And that is the reason I said, अगर आपको insertion समझ में आता है, insertion sort is very easy. Very easy. It is that simple. Chalo, go ahead. I'm repeating it once again for you. I'm repeating it once again for you. What I'm saying, you consider initially array is of two elements only. Array is of two elements only. And obviously अगर array is of two elements होगा तो I is equal to 1. I is equal to 1 will be like a smallest what is that, will be the last element. हम लोग पूरा array देख ही नहीं रहे, हम लोग सिर्फ दो का array देख रहे हैं. तो हम लोग कह रहे हैं कि I is equal to 1, that is my last index. If that is my last index, you take out 4, and you start comparing with all elements before that. You start comparing with all elements before that. Okay, that is good. You find that 6 is greater. अभी हम लोग insertion technique follow कर रहे हैं with the array of 2. 4 is taken in a temp, and then you are following the technique. So you find that 6 is greater than this. You shift this, and there is nothing to compare. There is nothing to compare. You want to insert this at the location 0. Done. So now my array of 2 is sorted. Array of 2 is sorted. Let me continue further. Repeat the same process. Now repeat the same process for array of 3. Now let us focus on array of 3 where we have got 3 elements, and at this moment I can consider that this element, I can consider that this element is not sorted. If this element is not sorted, what is to be done? Take out this element, and start comparing with all elements before that. So you find that 6 is greater, shift that. 4 is greater, compare with 4. 4 is greater, shift that. There is nothing to compare, you insert 2 at the 0th location, and you continue further. Just now you sorted array of 3. You continue further. Let us consider the array is of 4 elements. If you consider arrays of 4 element, the 4th element was nothing but 8, and you say I is equal to 3 over there, and you start comparing. Again, you take one element out, you compare with all elements before that. I hope आप लोगों को समझ में आ रहा है. You compare with all elements before that. पहले दूसरे इटरेशन में नहीं भी समझ में आया, तो इसीलिए तो हम लोग एक एक चीज के हम लोग चार इटरेशंस, पांच इटरेशंस कर रहे हैं, so that you can see the same iteration is getting repeated again and again. I'm saying that this is the last element of the array, and compare with all elements before that. So you start comparing. You find that 6 is greater than 8. Shift. 4 is greater than 8. No, sorry, my mistake. 6 is not greater than 8. 6 is not greater than 8. So you find that in this particular case 6 is smaller than 8. So you want to simply add the element after this. Okay, that is also done. So यहाँ पर 8 के लिए आपको internal सारे passes करने की जरूरत ही नहीं पड़ी. Oh, that was easy job. You continued further, and now you consider array of 5 elements. Which is the fifth element? Fifth element is 3. You copy that. It is added over there. मैं आपको उतना ही array दिखा रहा हूं. I'm just saying that you focus only on that part. So here I is equal to now 4. And you take out that element. Whichever is the last element, you take it out and start comparing with all elements previous to that. 8 is greater, shift. 6 is greater, shift. 4 is greater, shift. And then you find that there is nothing. 2 is smaller than 3. So you want to insert it at the place. Done. Finally we have got array of 6, जो कि अपना original array था, his array of 6, and the element that was there was, let's say, 1. Again, I am considering that this was the element which is like unsorted. If this is element unsorted, I is equal to 5, and then you continue the process. You take out 1 in a temporary variable, start comparing. You find that 8 is greater, shift. 6 is greater, shift. 4 is greater, shift. 3 is greater, shift. 2 is greater, shift. Nothing to compare. You put in 1 at the appropriate location. Is this clear? I guess that is what algorithm is. That's why I was saying that just focus on a basic part first. Advanced part will automatically done. So how do I change this code? Very difficult or not at all? Changing this code is very easy job. Please pay attention. For कहाँ से I शुरू करना है? I शुरू कहाँ से करना है? कहां से कहां तक आई रिपीट करना है. टेक अ लुक एट द पेपर. 1 से लेके लास्ट इंडेक्स तक. एम आई करेक्ट? 1 से लेके लास्ट इंडेक्स तक. सो आई इज इक्वल टू 1. I is less than AR dot length I plus plus. Okay, that is good. And each time we are saying that it is the last element of the array. If ith element is the last element of array, please pay attention. Ith element is the last element of array. Done. If ith element is the last element of array, the element before that, ith element se pehle, I minus 1, I want to compare till last element, j is greater than equal to 0, and j every time you are doing a shifting, that is done, it's over. Nothing much I need to do. Nothing much I need to do. So is it sorted? Yes, it is sorted. That is what you call it as a insertion sort. That is what insertion sort. What we are doing is that over here we say that n minus 1 passes. N minus 1 passes, and in each pass, consider ith element as last element of array. Last element of array. Then compare or copy last element into temporary variable. Compare temp with all elements before that. Find appropriate position for the element and insert temp at that position. And that is what we have done, kind of insertion technique. That's it. Janvi ka kuch question hai? Why I is not why not I is less than error dot length minus 1? Janvi, take a look at this. Initial value is I is equal to 1. Last value is equal to I is equal to 5. The array is of total 6 elements. Array is total 6 element. So 6 minus 1 is equal to 5. That's it. This is what all I'm looking for. यहाँ पर मैंने क्या लिखा है? AR dot length लिखा है. ए लेंथ लिखा है, मतलब ये कहां तक जाएगा? टिल n minus 1 तक जाएगा. अगर आपको लेंथ minus 1 लिखना है, all I need to do is that, अगर आपको लेंथ minus 1 लिखना है, all I need to do is to use less than or equal to sign. क्योंकि ultimately my aim is that I want to consider even the last element as an unsorted element. यहाँ पर पहला एलिमेंट एज अनसॉर्टेड कंसीडर करना है, उसके बाद में इसको अनसॉर्टेड कंसीडर करना है, फिर इसको अनसॉर्टेड कंसीडर करना है, फिर इसको अनसॉर्टेड कंसीडर करना है, फाइनली इसको अनसॉर्टेड कंसीडर करना है. Isn't it? Even last element is to be considered, right? And that is the reason. But ये लिखने से ये ज्यादा अच्छा लगता है. Done? Okay, that is good. सर ये काम करता है क्या? ओ काम करता है क्या? That is a question. पहले करके देखते हैं. Insertion sort ARR. I guess कुछ लोगों ने करके देख लिया है. And you find that yes, my array is still sorted. My array is still sorted. I hope everything is all right. Why don't you try it at your end? Go ahead. By the way, if at all you are finding that I'm going too slow, let me know that as well. Good. So we started talking today about this. Yes, Pooja. No, I'm not actually talking about that. So there are few people in your batch which are like, extra intelligent, and then they usually keep saying that I should take simple topics at bit faster rate. So if you really want I should go fast, please tell it on a common platform, so that really, everyone will accept it. If everyone accept it, I really don't have any problem. We can always speed it up. So at the end, at the end of the module, is that नहीं sir, sorting थोड़ा fast पढ़ाना चाहिए था. So if you want, just tell me on a day one itself and tell it in front of all the class. Not like, tell me personally, sir, you are going too slow. Please increase your speed. Let us go with the class, not for like one individual. Error of z plus 1 temp in an inner loop. Still it work? Yes, it is. But then again, Namrata, why are you doing that? Let us understand algorithm and then do it. Not doing a trial and error, isn't it? Okay, that is good. Chalo. So we have completed the bubble sort, we have completed insertion sort. अगर आपका algorithm हो गया है, what about the time complexity of this algorithm? Oh, I want to study that as well. A time complexity of that algorithm. Chalo, go ahead, compare it. How many maximum iterations are happening in like a first pass? How many maximum iterations are happening in a first pass? Have you noted? पहले पास में कितने iterations हो रहे हैं? What we are doing? We are comparing this element with all elements before that. One iteration, yes, correct. And then in a second pass, there will be 2 iterations. In a third pass, there will be, let's say, 3 iterations. And the next pass, there will be, let's say, 4 iterations. And the next pass, there will be, let's say, 5 iterations. So number of iterations that are happening in each pass, maximum iterations I'm talking about. I'm not saying total number of iterations. क्योंकि अगर आप लोगों ने ठीक से नोट किया, in this case, ये वाला अगर आप लोगों ने एग्जांपल चेक किया था, यहाँ पर 8 हम लोगों ने बाहर निकाला और immediately अंदर डाल दिया. In this particular case, even none of the earlier iteration was done. I'm just saying that the maximum number of iterations whichever are possible are hardly, अगर आप लोग इसको प्लस करते हो, like a 15 iterations. So I guess the formula is pretty simple. The number of iterations, total number of iterations are nothing but it is 1 plus 2 plus, you continue further on each iteration up to n minus 1. And if this is arithmetic progression, you know the answer of that as well. So number of iterations are still n into n minus 1 by 2. I hope you got that. And if it is so, this is exactly same as of selection sort or kind of improved bubble sort that we have seen earlier. I can simply say that the time required is proportional to n square minus n. 1 by 2 is constant, you take it out, and then the time complexity comes out to be O n square only. If you people have really understood this, I want you people to try it one more on paper. Try it one more on paper. And what to try? Please try it. What if your array is already sorted? Take this array and do it on paper and count how many iterations of the inner loop are done. Count how many iterations of the inner loop are done in each pass. In each pass, how many iterations of the inner loop are done? बहुत सारे लोगों का प्रोग्राम करके हो गया है. I said that you are already ready with the paper and pencil. Take this and again you need to follow the same logic. क्या करना है? You need to take this element out, compare with all previous element, find the appropriate position and put that element back to the place. This is what all you need to try it. So Malika, I guess you are talking about 5 iterations in all passes together, right? So one for each pass, absolutely correct. One for each pass, total probably 5. So you find that in this particular case, take a look at this. You take 2 out, but you find that this element itself is greater. So you want to put it in a place. Your first pass is completed. Then you take this out, you compare with all previous element, but again you find that this element itself is smaller, you put it back to the place. You take this element out, you find that the previous element itself is smaller, you put it back to the place. Again, Then you again find out that this element is 1. So again you put it back to the place, and again you take this element out, and again you find that this element is smaller, again you put it back to the place. So you find that the inner loop probably hardly one iteration is done. So what is the time complexity in this case? In this case आपका inner loop वैसे भी execute हो ही नहीं रहा है. So you find that the total number of iterations will be directly proportional to the number of elements, and then the time complexity is of order of n. By the way, हम लोग ये क्या पढ़ रहे हैं? What is this? जो भी पढ़ रहे हैं उसको क्या कह रहे हैं? Yes, special case, like a best case. The best case time complexity for your insertion sort will be O of n. That's it. So this is all about kind of a sorting algorithms, basic sorting algorithms. There are 3 more left, like heap sort, merge sort, quick sort, that we will see it sometime later. When you are like more comfortable with the recursion and all that, at that time we will talk about that. You have got any question regarding sorting? Whatever we have learned so far, this is like good time to ask. And if there are no questions, I would move further and I'll start talking about the next topic, what do we call it, the linked list. Good. So far, what we are using is kind of arrays. And you know that arrays are great data structure. Rather, trust me, arrays is Deepak has got some question. Can we use recursion in the insertion sort? Deepak, yes, you can. See, finally, मैंने आपको कल ही recursion already पढ़ाया था, and I said that it is a divide and conquer technique. So in any problem where you can apply the divide logic by yourself, you can always convert it into the recursion. तो सर insertion sort में recursion हो सकता है क्या? My answer is yes. And if you want, go ahead and try to do it. Is that okay? I'm not really going to, show it in a class. I do not really want to confuse everyone. Anyone you are interested, please go ahead, do it. If you could not do it, let me know personally. I can help you. No problem. Regarding. चलो अब हम लोग आप थोड़ा सा पीछे जाते हैं and we will talk about something. Linked list definitely I want to learn. Linked list definitely I want to learn. But before I go ahead with the linked list, many time what people ignore is arrays. मैं फिर से बता रहा हूँ, arrays are fastest data structures and arrays are like most commonly used data structures. बहुत बार हमको पता नहीं होता, वो बात अलग है, but arrays are data structure, commonly used data structures. There are some special properties of arrays, and very first property of an array, can you please tell me what is the special properties of arrays? What are the special properties of arrays? How you will say that? What are characteristics of arrays? The very first characteristic of array, अगर आप लोग abstract data type के point of view बात कर रहे हो, definitely you can say that it can provide you random access. And what is random access? You say that I want to access 4th element. You say that I want to access 10th element. You say I want to access 1000 element. You access any element at any moment. It is absolutely allowed. It is random access. The second one. Second characteristic, I can say that yes, obviously the random access is always a fixed time. Fixed time. The second important thing you talk about is the size is fixed. It is fixed size. A fixed size simply means that you cannot change the size of allocated array. आप लोग allocation, see, you can do the static allocation, you can do the dynamic allocation. Whether you allocate statically, as far as C++ is concerned, you can always allocate the array statically. Where you write that int arr of 5. So it is static allocation. लेकिन अगर आप लोग C++ या C में करते हो तो अगर malloc या new operator are there using which you can also allocate it dynamically. So what I'm saying is that let it be the static allocation, let it be the dynamic allocation, let it be the static allocation, let it be the dynamic allocation. While creating an array, you need to specify the size. And the size, once you created array, thereafter size is going to remain same. You cannot change the size of existing array. That is the meaning I said fixed size. So in other words, I'm saying that this cannot grow or shrink at runtime. After creation, इसको grow और shrink करने का कोई chance नहीं है. This is there. Then you continue further. You got a third point. What is third point? As someone has said, internally arrays are contiguous allocation. Now, but this is like internals. Definitely, that is fact. The arrays are contiguous allocation. Now, these are 2-3 points that you must be knowing with the arrays. एक और चीज going ahead. क्या पर गया? A random access, one. Fixed size, yes, second. Contiguous allocation, third. And I'm saying that there are no overheads. No overheads. No overheads का simply मतलब है no extra space required other than data elements. So अगर हम लोग कह रहे हैं कि मुझको array of 4 integers करना है, अगर मुझको array of 4 integers करना है, then array of 4 integers will take 40 bytes. Assuming that एक integer का size है 4 bytes, so array of 10 integers will take 40 bytes. It will not take 42 bytes or 44 bytes or 50 bytes. It will not take any extra space. So there are no overheads are there. These are certain highlights that you should be knowing. And since it is random access, since it is contiguous access, you can always find it that it is like a faster. It is faster. Rather, the fastest data structure is array itself. तो जहां जहां पर पॉसिबल है, आई ऑलवेज रिकमेंड दैट गो विद द एरे. अननेसेसरी शाइनिंग मारने की जरूरत नहीं है कि मेरे को लिंक लिस्ट आता है. अगर आपको पता है नंबर ऑफ एलिमेंट्स आपके कभी चेंज नहीं होने वाले, देन यू ऑलवेज लुक फॉर गो विद द एरे. मेक इट कंफर्टेबल. अननेसेसरी फैंसी कोड लिखने से आप कोई इंटेलिजेंट नहीं हो जाते. जहां पर जरूरत है जरूर लिखना, लेकिन जहां पर जरूरत नहीं है, अगर एरे से काम बन सकता है, आई ऑलवेज रिकमेंड दैट गो फॉर इट. नाउ I'll give you a scenario. Again, as I said that, मैंने आपको पहले लेक्चर में बताया था, this data structure is all about thinking process. It is all about thinking process to start with. So let's say that I have got a class of 50 students. I have got a class of 50 students and I want to store all 50 students. What should I use? Which data structure is probably most suitable? It is a class of 50 students and yes, I want to store them. Yes, array is like most suitable data structure because मुझको पहले से पता है this is a class of 50 students. अच्छा, what if I have got, let's say I have got 10,000 alumni. I have got 10,000 alumni and I want to store the information of all 10,000 alumni. What should I do? Again, please go ahead with the array because you already know that there are 10,000 alumni are there. So this is again very simple one. Okay, I'll just go ahead. Now listen carefully. Now I'm looking for, let's say that we have sent email to all our alumni for something called as the alumni meet. So we have made a alumni meet, and in case of alumni meet, we send jitne sare alumni hai, we send emails to all. Obviously, even though we send email to all, I'm very sure not all can come. Why not all can come? Obviously, the few might be like out of station, few might be busy into their own work, few might be busy with their family. There are a number of things are there, you always know. So now let's say that the people, the alumni, they are coming one after another, and now as the people who are coming to the alumni, I want to store their information. एक एक बंदा आएगा, मुझको उसकी information store करनी है. एक एक बंदा आएगा, मुझको उसकी information store करनी है. Now in this particular case, what should I use? Should I use array in this case? Someone is saying dynamic array, but even in dynamic array, I cannot go with the dynamic array because dynamically allocate करने के लिए भी आपको size पहले पता होना चाहिए. So let's say that you see that कि अभी आपको गेट के ऊपर 3 लोग दिख रहे हैं, तो you are allocating array of only 3. So probably even by the time these people are entering, next 10 come together. So you want such a data structure where the size will vary. Probably ऐसा भी कुछ हो सकता है that you find someone कि like एक कोई तो आता है and then say that okay, So you just immediately allocate the memory for it. And then he says that, oh no, no, I'm not Sunbeam alumni. I was searching some other address. And then you realize that, अरे यार इसको हम लोग unnecessary add कर रहे हैं. So you might want to even delete that. So not only you want to grow it, sometimes you have done some wrong entry, you want to also shrink that. You want to also shrink that. So अगर आपको ऐसा data structure चाहिए, please note that array cannot be helpful. And for such kind of data structure, you need something new. You call it the linked list. I hope I tried to told you why linked list. So when arrays are there, why to go for linked list? The reason is there. Naneshwar saying that, but sir, without giving size, we can also create dynamic array. So this may also possibility. Naneshwar, I don't know how to allocate the array dynamically without giving a size. Can you please help me with the code? How do you write it? Array dynamically allocate कैसे करते हैं without giving a size? I never came across such kind of code. You came across any kind of code? अच्छा ओके ठीक है, नो प्रॉब्लम. सो सॉरी. हाँ हम लोग कहाँ पर थे? So now this is a scenario where you go for a linked list, and what your linked list is saying, let me just go ahead. Linked list is a list of items linked together. Oh, again a very diplomatic definition. मैंने मैंने पहला diplomatic definition हमको बताया था शायद. What definition I told you? Data structure is the structure of a data. And now you ask me what is linked list? I simply say that linked list is a list of items, they are linked together. A kind of an example that can be given. You ever heard of something called treasure hunt? You ever heard of treasure hunt? What is treasure hunt? The treasure hunt where you see that, so there are, certain clues are given. So you find that there are like certain places, and then from each place you get some clue, and from each place you get some clue, you get a clue, you go to the next, you get a clue, you go to the next, you get a clue, you go to the next, and finally somewhere you see, oh, there is some treasure, there is some treasure. This is something that you are trying to look for. तो ये जो है, this is a real world kind of example. You can say it is a linked list. What is a linked list? Like a treasure hunt, that at any moment you do not know which is your last element, or any moment you do not know what is your third or fourth element. At every place, we are going from the first place, we are getting a clue from there, we are going to the second, we are getting a clue from there, we are going to the third, we are getting a clue from there, and then we are going to the next, and this way you are continuing everywhere. This is what a real life example. But in this case, linked list में इसको क्या कहते हैं? Each item is referred as a node. Each item is referred as a node. And then what node contains? Oh, each node contains some data. Each node contains some data, and it contains reference to the next node. So you have written a word pointer there. हाँ, I have written a word pointer there. So C++ के लोग probably pointers कहते हैं. And the people who come from a Java or C# background, who has got misunderstanding that Java doesn't have pointer, they use the word references. कोई बात नहीं. So I'm saying that each node contains the data and it contains the reference to the next node. So ultimately, you understand that like array, linked list is also the linear data structure. But then you ask the question, what is the advantage of linked list over the array? Or advantage of linked list over the array, the biggest advantage. What is the biggest advantage? The biggest advantage is that it can grow or shrink at runtime. Isn't it? Yes, it can grow or shrink at runtime. So specially लोग लिंक लिस्ट तब यूज करते हैं, स्पेशली लोग लिंक लिस्ट तब यूज करते हैं जहां पर आपको नंबर ऑफ एलिमेंट्स पहले से पता नहीं है. आपको नंबर ऑफ एलिमेंट्स आपके ग्रो भी हो सकते हैं, श्रिंक भी हो सकते हैं. प्लीज नोट, एरे का साइज कभी भी चेंज नहीं होने वाला. जो कुछ भी एरे का साइज है वो हमेशा फिक्स ही रहने वाला है. इवन दो यू हैव गॉट एरे ऑफ 10 एलिमेंट्स एंड नाउ यू से दैट आई डोंट नीड 3 एलिमेंट्स, you don't need 3 elements, you will not going to change the size from 10 to 7. It is not possible. I'm saying that with the linked list, the elements जिनकी जगह आपको नहीं चाहिए, आप उनको रिलीज कर सकते हो। दैट इज डेफिनेटली द पॉजिटिव साइन, पॉजिटिव साइड ऑफ अ लिंक लिस्ट। बट एट द सेम टाइम there is some negative side as well. What is the negative side of this? In linked list, ये treasure hunt है. Since it's a treasure hunt, directly jumping on a last node or directly jumping on in between node is not possible. So I'm saying that this is only good for sequential access. This is only good for the sequential access. ये सिर्फ sequential access ही दे सकता है, ये आपको random access नहीं दे सकता. That is unfortunate. I hope you got that point. So यहाँ पर, so I want to jump on like nth element. It is not possible. Not possible in the sense it is slower process. Let's say that a given a place. So मुझको चौथे element पे जाना है. Can I go to the fourth element? Yes, you can go to the fourth element, but not directly. You want to go to the fourth element, go to the first, second, third, fourth. So I'm saying that the sequential access only. हाँ, traverse करके जा सकते हो. Random access is going to be slow. That is second. What is third thing? What is third thing? The another, probably you can say drawback. You can say that overheads. Overheads. What is the overheads? So I'm saying that you have got each pointer, each node has got a pointer to the next node. Each node has got a pointer to the next node. So when you say that हर एक नोड में आपको कुछ ना कुछ तो रेफरेंस रखना है, हर एक नोड में आपको कुछ ना कुछ तो रेफरेंस रखना है. तो अगर आपके पास 100 नोड होंगे तो आपके पास 100 रेफरेंसेस एक्स्ट्रा होंगे. अगर आपके पास 10,000 नोड होंगे तो 10,000 रेफरेंसेस एक्स्ट्रा होंगे. जस्ट फॉर योर इंफॉर्मेशन, आई होप आपको ये पता है, द रेफरेंसेस आर लाइक पॉइंटर्स. References are like pointers. They are also going to take some memory. 4 byte memory, 8 byte memory, कुछ ना कुछ तो memory वो अलग से लेने वाले. So I'm saying that you just think of it कि आपको array of integers बनाना है. आपको array of integers बनाना है. 10 इंटीजर का कर आपको एरे बनाना है. 10 इंटीजर का एरे बनाना है, आपको सिर्फ 40 बाइट लगते हैं. लेकिन अगर आपको 10 इंटीजर की लिंक लिस्ट बनानी है तो इंटीजर के लिए तो 40 बाइट लगेंगे, प्लस 10 एक्स्ट्रा पॉइंटर्स आपको लगने वाले हैं. और जो 10 एक्स्ट्रा पॉइंटर्स आपको लगेंगे उसकी साइज लेट्स से अनदर 40 बाइट्स और अनदर 80 बाइट्स. दीज आर द ओवरहेड्स फॉर यू एंड नथिंग मच यू कैन डू. नाउ व्हेन इट कम डाउन टू द लिंक लिस्ट, व्हेन इट कम डाउन टू द लिंक लिस्ट, which operations, yes obviously ये बताने की जरूरत नहीं है कि लिंक लिस्ट की जो भी मेमोरी आएगी, द लिंक लिस्ट मेमोरी इज नॉट कंटिग्यूअस. लिंक लिस्ट, इट इज नॉट contiguous allocation. Linked list memory is not contiguous allocation. Please understand this. So I talked about what is linked list. I talk about, let's say, arrays. It is there. And now it's time to talk about linked list as an abstract data type. ये हमने कल के लेक्चर में पढ़ा था, abstract data type. Every data structure is kind of abstract data type only. And if it is abstract data type, what are the common operations? What are the common operations that can be performed on a linked list? I said that the common operation that can be performed is, let's say, add first, saying that I want to add the element at the beginning. Add last, I want to add the element at the end of the linked list. I want to add the element at the given position in a linked list. I might want to delete the element at the start. I might want to delete the element at the end. I might want to delete the element at the given position. I might want to delete all the elements. I might want to delete all the elements. So not only that, if you at all look for extra, you might think of a method like traverse, or you may consider even a simplified method, let's say display, and so on and so forth. आपको जो चाहिए वो आप लोग यहाँ पर डाल सकते हो. This is absolutely possible. Now these are commonly used operations. और जहां तक मुझको पता है, आपको ये अलग से बताने की जरूरत नहीं है. यू पीपल हैव लर्न जावा. जावा के अंदर जावा का खुद का एक लिंक लिस्ट का क्लास है. जावा का खुद का लिस्ट इंटरफेस है, which is already telling you which all operations are there. Obviously the names might differ. So जावा में कुछ तो add first, add last, sorry, हमारे यहाँ पर हम लोग add first, add last ऐसे नाम यूज कर रहे हैं. They might have used the different name, the names like add, name like insert, name like some of the remove. तो उन्होंने अलग अलग नाम यूज किए, उससे कोई फर्क नहीं पड़ना चाहिए, right? Let us take a look at what all different types of linked lists are there, and then we will take a break, so that after the break we will focus only on implementation. So we say that commonly speaking, there are four types of linked list as far as the internal structure is concerned. Which are four types of linked list? The first type of linked list, we call it a singly linear linked list. What is singly linear linked list? You find it over there. In a singly linear linked list, the first node, the first node, each element is a node, node, node. Each element contains two things, data and pointer to the next node. This is a node, node, node. Each element contains data and pointer to the next node. Data and pointer to the next node. This is how you are trying to make a linked list. Now, how the things are doing? You find it there. This is nothing but the head pointer. Head pointer is a special pointer. Head pointer is a special pointer that keeps the address of the first node. Sir, ये 100, 200, 300 क्या है? I just written some numbers to indicate the addresses. So it is head node is pointing to the address of the first node. It is 100, and then it contains the address of the next node, which is 200, which contains some data and a pointer to the next node, which is 300. And this is a singly linear linked list. Last element in this linked list is null. Null in the sense it is not pointing anywhere. You can say that कि this is your end of your treasure hunt. अब यहाँ से आगे आपको और कहीं पर जाने की जरूरत नहीं है. Singly linked list. Why it is singly? Because each node hold a single reference to the next node. Why it is a singly linked list? Because each node hold a single reference to the next node. But other way around, there is also something called a doubly linked list. What is doubly linked list? The doubly linked list, you should be able to see it over here. Something similar. Each node contains data and pointer to the next node. Data and pointer to the next node. Data and pointer to the next node. So ये तो पहले भी था. अब नया क्या है? Now extra thing is that each node contains a pointer to the previous node as well. So what exactly it means? Have a look at this. पहले basic head node is containing the address of the first node. Good. The first node containing address of next node. This node contains the address of next node. Last node contains null. Okay, that is quite good. You go in the other way around. Other way around, what is that? The last node is containing the address of the previous node. This node is containing the address of even previous node. And the first node is again, it is null node. Here, each node contains data and pointers or references of two nodes. One is next, another is previous. And that is the reason this is said to be doubly linked list. This is said to be doubly linked list, doubly linear linked list at the moment. You continue further. The next part, we are saying that singly circular linked list. So what is circular linked list? It is like, अगर आप लोग singly linked list की बात कर रहे हो, it is like this linked list only. However, singly linked list only. Over here, this is pointing to the first node. The first node is keeping address of the second node. Second node keeping the address of the third node. But the last node, you see that it is not null. It is keeping the address of the first node. And this part is nothing but circular. What is circular? Circular simply means that the last node contains the address of the first node. Last node contains the address of the first node. You start calling it as a circular linked list. So, sir, is it possible to have doubly circular as well? Yes, doubly circular as well, where last node keeping the address of the first node and first node keeping the address of the last node. That's it. Rest everything is very simple. These are four different types of linked lists. This is singly circular, this is doubly circular. I hope ये आपको already सुन के पता होगा. I'm very sure. Have you people written any simple linked list in Java? जावा में आपने कोई बेसिक लिंक लिस्ट लिखा था क्या जावा के मॉड्यूल में यस कुछ लोग यस कह रहे कुछ लोग नो नो कह रहे सो कुछ कॉम्बिनेशन आर देयर कोई बात नहीं वैसे भी हम लोग डेटा स्ट्रक्चर पढ़ रहे हैं तो वैसे भी वील हाँ सिंगली लिंक लिस्ट वॉट एवर कोई भी लिंक लिस्ट हो उससे कोई फर्क नहीं पड़ता, वैसे भी वी आर गोइंग टू राइट इट फ्रॉम स्क्रैच ओनली. सो वी आर गोइंग टू टॉक अबाउट हाउ टू राइट द नोड, how to write the list, and like each and every point. W linked list, here you go. What is the W linked list? The W linked list is one where each node contains the address of the next node. Each node contains the address of the next node, but at the same time, each node contains the address of the previous node. Each node contains the address of the previous node. I hope Amit that is clear. हर एक नोड के अंदर आपके प्रीवियस नोड का भी एड्रेस रहता है. दैट इज व्हाट यू कॉल इट एज अ डब्ली, दैट इज कॉल्ड एज अ डब्ली लिंक लिस्ट. सिंस देयर आर टू पॉइंटर्स, दैट्स व्हाई इट इज रेफर्ड एज अ डब्ली. नथिंग ग्रेट, डोंट वरी. वैसे भी हम लोग इसका प्रैक्टिकल करने ही वाले, हम लोग हर एक लिंक लिस्ट का प्रैक्टिकल करने वाले. टू स्टार्ट विथ, ऑब्वियसली विल फर्स्ट स्टार्ट विद द सिंगली लिंक लिस्ट. विल राइट अ प्रोग्राम फॉर सिंगली लिंक लिस्ट. Listen, before you take a break, usually my method of teaching data structure is very simple. The first linked list I teach at most slow rate. जिस स्पीड से आप लोग कहोगे उस स्पीड से हम लोग पहला लिंक लिस्ट पढ़ेंगे. बिकॉज जिसको पहला लिंक लिस्ट आ गया, जिसको पेपर वर्क आ गया, जिसको अल्गोरिदम डेवलप करने आ गया, दैट पर्सन कैन ऑलवेज राइट द कोड फॉर अदर लिंक लिस्ट. So today I'll be focusing, rather it is absolutely fine even though we learn a single linked list till the end of the day today. It is absolutely no problem. So we will go very slow. Any questions are there, your every question is welcome today. You understand, you ensure that you are able to do the paperwork with me. Any paperwork is not clear, any line of code is not clear, please do ask immediately. We will sort out this. I'm talking mainly to those people who are still weak in linked list or like never learn linked list before. ऐसा होना नहीं चाहिए आइडियली, क्योंकि आप लोगों ने सीकेट एग्जाम दिया है, बट स्टिल सर तब नहीं पढ़ा था, तब सिर्फ रट्टा मारा था, वट एवर. दिस इज आइडियल लेक्चर. डू नॉट एक्सपेक्ट मी to go like every next linked list in equally slow speeds. So usually first 2 hours we will learn probably one linked list. Next 2 hours we will learn rest 3 types of linked list. So please be prepared for that. So today's lecture, lab after that, and paperwork. This is very important if you want to understand the tomorrow's lecture. So be prepared mentally, have a cup of tea, make yourself fresh, and then we will continue further. Let's go. I'll just put a timer. I hope you are there. And let us get started with linked list. And as I said that we will be learning all these linked list, not only conceptually but also practically. What is important is to understand how do we draw the diagram and how do we build a code from that. The technique remains same. The technique remains same for all the linked lists. And trust me, not only that, the same technique continued further for the trees or even graphs as well. I do recommend that if you are already expert into the linked list, still take linked list seriously, do all paperwork once again, make yourself comfortable, and see whether you can build the code from the diagram. See, usually people by-hat the code. That is not really a good idea. Linked list is probably the easiest data structure where you learn how to draw the diagram and how to build the code on the fly. So if you get a skill of building the code on the fly, I believe you have conquered the data structure, right? But if you miss that, then there is a problem. Then जैसे जैसे मॉड्यूल आगे जाता है, जैसे like linked list कुछ लोग रट्टा मार के मैनेज कर लेते हैं, and then they find trees very difficult, they find hashing even more difficult, they find graph is impossible. So this is ideally time, and you are lucky that you are getting a new year gift like linked list. So today and tomorrow we'll be talking about a linked list, the greatest gift ever. So getting back, we will continue further, and we will start talking about singly linked list, the actual implementation. So what we will start about, we will say, as I already told you, linked list is basically the abstract data structure. Abstract data structure, so internal implementation may vary from type to type linked list. It may vary from programming language to programming language. What will remain same, what will remain common are the basic operations. So what I'm planning is that we'll start with all operations one by one, and then for each operation we will see how we can implement that, right? So let us just get started. And very first concept that I need to talk about before we even go ahead, that how this linked list is to be represented in an object oriented world. Okay, in an object oriented world, how this linked list can be represented? क्योंकि पहले लिंक लिस्ट अगर आप लोग रिप्रेजेंट करोगे तब जाके बाद में हम लोग सोचेंगे इसका कोड कैसे करना है। पहले लिंक लिस्ट को रिप्रेजेंट करने आना चाहिए। तो you understand that right now what we say, that linked list is list of nodes connected to each other. If I say that linked list is list of nodes connected to each other, the very first thing the very first thing that I see is that it is in object oriented world. You can say that linked list is like a class. You can say linked list is like a class. So you can say that you can have a class which is representing a linked list, a class which is representing a linked list, and then we'll have all its operations. Now what sort of operations? Just now you see that the operations are like, अब मैं बार बार पब्लिक नहीं लिखने वाला इसलिए मैंने एक बार लिख दिया है. You see that rest, it is, you can consider it for all together, right? So which all operations? I'm saying that one of the operation like display operation, another operation like add first operation, another operation like del first operation, another operation like add last operation, another operation like added position operation, and this way there will be number of operations that we will be writing one after another. The question is that what should be there into the data? Or data is nothing but linked list. And what is linked list? Linked list is list of node connected together. A linked list is list of node connected together. So very first question that you should be having is that what basically one node is. You see it very well that node has got two parts. Each node has got two parts. One is the data and another is kind of a pointer to the next. One is the data and another is pointed to the next. तो सर डेटा कौन सा टाइप का होगा? जिस टाइप की आपको लिंक लिस्ट बनानी है. अगर आपको लिंक लिस्ट इंटीजर की बनानी है तो शायद आपका डेटा इंटीजर होगा. अगर मुझको लिंक लिस्ट एम्प्लॉय की बनानी है तो देन डेटा शुड बी लाइक एम्प्लॉय. अगर मुझको लिंक लिस्ट प्रोबेबली लेट्स से स्टूडेंट की बनानी है देन द डेटा विल बी लाइक स्टूडेंट. सो इट इज अप टू यू, बट अल्टीमेटली यू अंडरस्टैंड दैट each node contains two things. Each node contains two things, and linked list, the linked list, when you say linked list only contains the starting address that is referring to the first node. Thereafter, you see that each node contains the address of next, each node contains the address of next, each node contains the address of next. So अगर आपको लिस्ट को रिप्रेजेंट करना है तो उससे पहले हमें क्या पता होना चाहिए? वो उससे पहले हमें पता होना चाहिए what is, let's say, class node. And what should be there in a class node? Or class node, there should be two data elements. One, some data, whatever a type कौन सा चाहिए वो आप लोग डिसाइड करो, of any type. So there should be a data, there should be a data. And the second thing, I want a reference to the next node. I want reference to the next node. That is something I'm looking for as far as data is concerned. Please note, this is nothing but data. And as far as operations are concerned, you can write your basic operations like constructor. You can write the basic operations like getter setters if you are interested in. So वो आपकी मर्जी है वो आपको क्या क्या लिखना है. But that is what you can make a class node. So node, each node contains two parts. One is the data and then pointer to that. And what is the linked list? The linked list, I simply say that the linked list is nothing but address of the first node it contains. So address of a first node, you can simply make node head. You know that this head is nothing but ultimately going to be a pointer. So this is going to be my data and these are going to be my operations onto the linked list. So ultimately, when we make a linked list, ultimately When we make a linked list, the linked list will be represented in a OOP world using a linked list will be represented in OOP world using a class. The class list having some data, having some data, and then rest of the operations. You continue further, but each node itself is a kind of a class. Itself is kind of a class, and then it will have its own data in it. And obviously the operations are always there that we will be implementing one after another. Now my first question is that listen carefully. और अभी जावा का थोड़ा सा रिवीजन चाहिए क्योंकि अल्टीमेटली हम लोग डिसाइड कर रहे हैं कि इसको जावा से बनाएंगे. तो कैन यू प्लीज टेल मी, आई कैन ऑलवेज सी दैट लिस्ट has got multiple nodes, so kind of has a kind of relationship is there. My question to you is that क्या नोड बनाने के लिए लिंक लिस्ट का ऑब्जेक्ट होना जरूरी है? इज इट नेसेसरी? नोड बनाने के लिए लिंक लिस्ट का ऑब्जेक्ट होना जरूरी है? एब्सोल्युटली नो. नोड इज नोड एंड लिंक लिस्ट इज लिंक लिस्ट. Obviously they are related, but then once linked list object is created, then nodes can be added into that. So the best mechanism that is usually followed when it comes down to the Java, we say that these are connected to each other. How? So inside list, you make it as a static member class. Inside list, you make it as a static member class. Static member class. So what is the advantage of making static member class? Why not to make it as a separate class? If you make it a separate class, typically your data member will be private, and the private data members you will be always accessing, with the getter and setter and all that kind of complications. It is not really required. Typically, even node class that usually makes sense only with the list class, isn't it? So it is always a common practice when it come down to the Java. I'm going on a Java specific. When you come down to the Java, it is always a common practice that you make a node class as a static member class of this. If you ever come from C++ background, तो C++ में हम लोग static member class बनाते हैं क्या? C++ में nested classes का कोई टॉपिक ही नहीं है. तो वहां पर nested classes होते हैं, but not like Java, static member class, anonymous inner class, that kind of topic is not there. So in C++, a very common methodology is to use a concept of friend classes. तो वहां पर हम लोग list class को node class का friend बना दें. Now these implementations usually goes language specific, and a standard practice in Java जब भी आपको बनाना है, so you make first of all node class, and that node class should be the member class of your list class. Member class of your list class. और वो भी कैसा member? A static member class. फिर से एक बार, आपने ऑलरेडी नेस्टेड क्लासेस पढ़ लिया है, मैं फिर से एक बार बता रहा हूं why it is static member class. Why it is static member class? Because I'm saying that to create object of node, to create object of node having object of my list is not mandatory, mandatory, and that is the reason you go for static member class. If at all is the case, नहीं से inner class का object बनाने के लिए outer का object होना जरूरी है. In that particular case we go for नॉन स्टैटिक मेंबर क्लासेस. अगर आप लोगों ने जावा में इटरेटर पढ़ा है तो टिपिकली इटरेटर्स आर क्रिएटेड एज अ नॉन स्टैटिक मेंबर क्लासेस. लेकिन जाने दो, हमारा इटरेटर अपना टॉपिक नहीं है. आई एम जस्ट ट्राइंग टू टेल यू कि व्हाई आई एम गोइंग टू इंप्लीमेंट इट लाइक दिस. वापस से ये आपको एक ही बार समझना है, क्योंकि सिंगल लिंक लिस्ट में जो स्ट्रक्चर करेंगे उसको कॉपी पेस्ट करेंगे और बचे हुए लिंक लिस्ट खत्म करेंगे. जो कंसेप्ट हम लोग लिंक लिस्ट में फॉलो करेंगे, एग्जैक्टली सेम कंसेप्ट हम लोग ट्री में भी फॉलो करेंगे. सो इट इज लाइक वन टाइम एफर्ट्स टू अंडरस्टैंड how to organize your code. So now, since I have understood a lot of organization now it's time we'll go back. As you see that break में मैं थोड़ा सा टाइम पास कर रहा था. टाइम पास किए कर रहा था because usually students like, so why you don't take the input from the user and all that. So I thought of taking the output. Amit, whatever I discussed was part of your Java code, and you people have already learned it into Java. Static member class, non-static member class, iterator class, node class, whatever is relevant over here, I'm just telling you. You can go back and revise your lectures of Java if you need it. I'm just going back. I'm saying that class singly list. The class singly list, and this list class, I want to make it as a node class. Node is static member class of singly list. You go ahead. So static class node, static class node. What all I need? I need the data members. अभी मुझको इंटीजर का लिंक लिस्ट बनाना है. अगर मुझको इंटीजर का लिंक लिस्ट बनाना है, I should simply say private int data. You continue further, and again you say private node next. All right, this is done. Going ahead, public node, and then inside this constructor. A constructor may, let's say data, I want to keep it 0. Let's say next, it is a pointer, I'm keeping it null. All right, you continue further. If you want, you can also think of having a parameterized constructor. The parameterized constructor where you are taking a value for the data and you are assigning that. I believe that such simple node class should be more than sufficient. Such simple node class is more than sufficient. And then we can continue on to the list members. So now I'm saying that singly list class data और data members इसको हम लोग कहते हैं fields. मैं यहाँ पर भी कमेंट लिख दूं आपके लिए, node class fields, and then you go ahead node class methods. I'm going ahead. ये आपका static member class था. I would suggest that इसको एक बार लिखो और एक बार लिखने के बाद में इसको मिनिमाइज करके रखो, क्योंकि वैसे भी आपको उसको बार बार एक्सेस नहीं करना है. And then you only know that there are two data members, one is data another is next. इसके अलावा कोई आपको दिमाग लगाना है ऐसे मुझको तो नहीं लगता, right? So you continue further and then you declare the fields. What is the field over there? I do not want to access it outside the class, so this node is nothing but as a head. Good. और जब मेरा प्रोग्राम शुरू होगा, जब मेरा प्रोग्राम शुरू होगा तो इनिशियली मेरे लिंक लिस्ट में क्या रहेगा? जब मेरा प्रोग्राम शुरू होगा एट दैट टाइम मेरे लिंक लिस्ट में कितने नोड रहेंगे? कुछ भी नहीं रहेगा. अगर कुछ भी नहीं रहेगा तो वेयर हेड विल पॉइंट टू, और वेयर हेड विल पॉइंट टू, हेड विल पॉइंट टू प्रोबेबली null. So you go ahead and you write a constructor. Within a constructor I want to simply say head is equal to null. A few people might be worried, sir, why you are not writing this dot head? Hey, this dot head, again using this into the what is that, classes, into the member function is always a good practice. Using this is always a good practice, no doubt on that, but I do not want to make my code complicated. I really do not have any habit of teaching other technology while teaching this. So जब मैं जावा पढ़ाता हूँ, at that time I focus कि what are the good OOP practices, what is this pointer, तो ये ऐसा करना चाहिए, वैसे करना चाहिए. When I probably come down to teach data structure, I usually focus onto the data structure part, right? So writing this is not compulsory, and in my opinion, many times using this every time in a data structure code, usually it deviates स्टूडेंट्स का प्रॉब्लम होता है कि वो दिस कहां पर लगाना है, दिस कहां पर नहीं लगाना है, उसमें इतना ज्यादा वक्त बर्बाद करते हैं कि जो डेटा स्ट्रक्चर का जो मेन एल्गोरिथम रहता है वो छूट जाता है. सो आई जस्ट वांट टू कीप इट सिंपल. आई जस्ट से दैट आई हैव डिक्लेयर्ड डेटा मेंबर एंड आई एम राइटिंग हेड इज इक्वल टू null, and then I'm going to write all the methods inside list class. So which all methods that I want to write? Oh, I want to write a method like a display. It's like one method. Probably I want to write a method of like say add first, like another method, the new node that I want to add. I want to probably add another method like say add last, एंड सो ऑन सो फोर्थ. तो आपको जितने सारे मेथड चाहिए उतने सारे मेथड्स हम लोग वन आफ्टर अनदर ऐड करने वाले हैं. मैं सारे एक साथ नहीं लिख रहा हूं, आई डू नॉट वांट टू कंफ्यूज यू. सो बट वी विल गो अहेड, वी विल टेक अप वन मेथड एट अ टाइम, we will do the paperwork of that method, we will try to build a logic on paper, and once we build a logic on paper, then we will continue from there. We'll continue from there. This is what we will follow. Let me just check if there are any question. Was there any earlier? I means why we are not using object there. Why we are not using object there? We are using object there. वैसे भी जब भी हम लोग node create करेंगे, we have to create a node and we have to create object of a node. We have to create object of a node. Hold on, let me continue. Let me create a linked list. दो चार operations हो जाने दो. I hope the things will be clear. Things will be clear. Not a problem. If things are still not clear, so definitely, if some topics are like out of the track, we can always discuss it at the end of the lecture. So I usually wait for you people, so you know that, not a problem. But then over here let us focus on data structure at the moment. चलो हम लोग कहाँ पर थे? So I was saying that this is ultimately the singly linked list, the class we have written. And then whatever operations that you want to do, see, you cannot do the operations on a class. Do understand that you have to do operations onto the, you have to do the operations onto the object. So somewhere you have to go ahead and you have to create the object of a singly linked list. Somewhere you have to create object of the singly linked list, and once you created object of a singly linked list, then you need to call all your methods on that object one after another. Somewhere you say that list dot display, yes you can. Somewhere you want to call list dot add first, yes you can. Or somewhere you want to call list dot add last, and this way you will keep adding, keep calling all methods one by one. सो अल्टीमेटली ऑब्जेक्ट हमको बनाना ही है, बिना ऑब्जेक्ट के तो वैसे भी प्रोग्रामिंग नहीं होने वाला है. बट एज आई एम सेइंग दैट लेट अस नॉट फोकस ऑन टू क्लास कब लिखना है, ऑब्जेक्ट कब बनाना है. लेट अस फोकस ऑन एल्गोरिथम एंड लेट अस जंप इनटू द कोड एंड देन work on to that. So let us go ahead, and the very first algorithm that I want to see, a very first algorithm that I want to see, how do I display the linked list? People ask the question, sir linked list तो अभी तक बनाया नहीं, why you are trying to display? I'm saying that let us assume that linked list is already created. Let us assume that linked list is already created. And if linked list is already created, my question is, how do I display the linked list? But to display the linked list, I'm very sure the very first question that should be in your mind, अगर linked list display करना है, मतलब basically display क्या करना है? What I'm saying is that linked list display करना है, मतलब basically display क्या करना है? Look at the diagram. Look at the diagram and can you please tell me, अगर linked list display करना है मतलब exactly इसमें से आपको क्या display करना है? What should be the output of this linked list? अगर मैंने ये वाला लिंक लिस्ट डिस्प्ले किया जो अभी आपको सामने दिख रहा है, अगर ये वाला लिंक लिस्ट मैंने डिस्प्ले किया तो एक्चुअल आउटपुट क्या आना चाहिए? एब्सोल्युटली इट शुड बी 11 22 33. What point that I want to make it is that, so I am not interested in printing कि इसका एड्रेस क्या है, इसका एड्रेस क्या है, इसका एड्रेस क्या है. I do not bother. When I say that I want to display the linked list, I want to display the data part in each linked list. That is good. So sir chalo, let us go ahead and let us try to display it. Try to display it. The likely chances are that you might think that, sir wo to theek hai, I want to display the first node 11. It is very simple. Why it is very simple? Because basically head is a pointer to the first node. Head is a reference to the first node. If head is a reference to the first node, I can always say head dot data. And if I say head.data, I can always say that, okay, print that. That will be like very simple job. So I can always have like kind of a printf function where I can print, sorry, I can have a printf function where I can write head.data. But the problem is that this will print only the head part. What about the next node and next node and next node? By the way, how many nodes are there in linked list? I said that I don't know. It's a treasure hunt. You never know how many nodes are there. And at a time, you cannot see all the nodes. So ultimately, logic that you need to follow is that you create, you get the address of the first node, you print that. From there, you get the address of the second node, you jump there, you print that, you print that. Again, you get the address of the next node, go there, and then print the next node, and you keep going, keep going, keep going until you reach null, which indicate that कि अब ये लिंक लिस्ट खत्म हो गया है, अब इस लिंक लिस्ट में कुछ भी नहीं है, अब इस लिंक लिस्ट में कुछ भी नहीं है. चलो आई अंडरस्टैंड इट वेल. तो सर लेकिन प्रॉब्लम इज दैट हाउ डू आई गेट द एड्रेस ऑफ द फर्स्ट नोड? Address of the first node that you can get it in a head, oh that is always available. And how do I get the address of the next node? Oh this node, जो कुछ भी नोड आपके पास है उसका जो नेक्स्ट मेंबर है, प्लीज नोट दैट जो डेटा मेंबर है इट इज अ डेटा, जो नेक्स्ट मेंबर है it is basically pointer to the next node, a pointer to the next node that is in front of you. So let us just go ahead and what do we do? Let us just go ahead and what do we do? To traverse the whole linked list, to traverse the whole linked list, what I will need is, what I will need is, I will declare, I will declare a special pointer. I will declare a pointer. When I use the word pointer, you can call it as like a reference. So you declare a reference called as a trav, and then you begin with the very first node. My first node is obviously 100, which you can take it from the head, which you can take it from the head. You can go ahead, you can print the travs data, whatever is the travs data, that you can print it. Oh, it is working well. But then what do you want to do? What is the next part to be done? What is the next part to be done? The next part to be done, now you want to go to the next node. But what is the address of next node? See the diagram carefully. जो लोग पहली बार पढ़ रहे हैं, जिनको ऑलरेडी लिख आता है, आई एम वेरी श्योर आप लोगों को बोर हो जाएगा, बट नथिंग मच आई कैन डू. I am trying to go as slow for the people who are learning for first time. So please pay attention, and you have any question, please ask early. Correct? So वैसे तो सबको आता है, तो usually it happens that then I am going fast and then sir वो समझ में नहीं आया था. Please don't do like that. So यहाँ पर if the trav, I am saying that I can always begin with trav is equal to head. Trav is equal to head. I get the address of the first node. I get the address of the first node. That is not a problem. I got the address of the first node. I simply say trav.data. I printed that. Now question is that I want to go to the next node. What is the address of the next node? Oh, address of next node is 200. But where do I get the address of the next node? Address of the next node, please make a note of this. ये यहाँ पर है. This is the data part. This is the next part. अगर trav.data, can you tell me at this moment what is trav.data? What is the value? At this moment, looking at the diagram, what is the trav data? Yes, trav data is 11. But can you please tell me now, looking at the diagram, what is trav next then? Look at the diagram. Trav next is nothing but 200. That 200, you can take it back into the trav. You can take it back into the trav. Meaning by earlier it was 100, now you make it 200. As you make it 200, I'm saying that now it is no more pointing. It is no more pointing to this node, no more pointing to this node, but now it has started pointing to the next node. It has started pointing to the next node. And then you want to again repeat the stuff. So initially, just now you have printed the 11, not a problem. You repeat the stuff. Now look at the diagram and tell me what is trav.data now. Already you have printed 11. Already you have printed 11, not a problem. My question is that what is trav.data now? Yes, trav.data is now 22. Okay, 22. So you printed 22. You printed 22. You repeat the process. Say trav is equal to trav.next. Now in this case, what is trav.next? Oh, trav.next, I see it is 300. 300 is copied back to the trav. If 300 is copied back to the this, what will happen? Now this is 300, and if this is 300, look at this. If this is 300, it will start pointing. It will start pointing to the new node. Okay, that is good. And again, probably I want to repeat the process. Again, I want to repeat the process. Now at this time, if I repeat the process once again, at this moment, what is trav.data once again? Now you find that trav.data is 33. Yes, you print 33. And again you say trav is equal to trav.next. Again you say trav is equal to trav.next. Now trav.next, you find that it is null. It is null. So ultimately, you understand that now this will be 0. This will be 0. This is not pointing anywhere. Now what do you want to do? Now what do you want to do? Do you want to repeat it further? No, I want to stop it over here. The question is, how do I stop it? How do I put a condition of my loop? The loop condition should be very simple. While trav is not equal to null. While trav is not equal to null, keep on repeating again and again, again and again, again and again. And that is the reason I'm saying that please do the paperwork. The biggest problem that usually happen with the data structure is that people tend to by heart the condition. Sir, वो trav is equal to null होता है, trav is not equal to null करना है, trav dot next is not equal to null करना है, trav dot previous is not equal to null करना है. I said that do not by heart the condition, follow with the flow. फॉलो विद द फ्लो, डायग्राम ड्रॉ करो और फिर खुद को क्वेश्चन पूछो कि मुझको कहां पर रुकना है. अगर आप लोगों ने क्वेश्चन ये बाहर किया तो लोगों का प्रॉब्लम क्या होता है? सो सिंगली लिंक लिस्ट में वी राइट ट्राइव इज नॉट इक्वल टू नल. नाउ यू गो ऑन द नेक्स्ट लिंक लिस्ट एंड पीपल से दैट सर अभी यहाँ पर ऐसा कंडीशन लिखा, वहां पर वैसा क्यों लिखा? Don't do that. क्या हुआ ज्ञानेश्वर? You are writing a wrong condition. That is the reason I am trying to tell you. आपको ही मैं बता रहा था that the condition should not be trav dot next is not equal to null. Condition should be trav is not equal to null. तो सर ये ऐसा क्यों होता है? यही तो मैं आपको कह रहा हूँ. Do not by heart and do not say that नहीं नहीं सर ये ऐसे ही condition होना चाहिए. Do the paperwork. Do the paperwork. You take a decision step by step कि आपको exactly कहाँ पर रुकना है. Are you getting? इसलिए आप लोग कह रहा हूं कि प्लीज बाहर मत करो सर. ये अब मैंने कहा ना, पहली लिंक लिस्ट में प्रॉब्लम नहीं आता है, दूसरे लिंक लिस्ट में प्रॉब्लम आता है. सर उस लिंक लिस्ट में ऐसे किया था, इस लिंक लिस्ट में ऐसे क्यों कर रहा है? डू नॉट मेमोराइज द स्टफ. अब इसमें आपकी गलती नहीं है. मैंने कहा ना, जो अवर इंडियन एजुकेशन सिस्टम इज रियली स्टूपिड वन. रियली स्टूपिड वन, ये मेरा पर्सनल ओपिनियन है. एंड दैट इंडियन एजुकेशन सिस्टम, in my opinion, that it tell you two things: how to use your memory and how to use your IO devices. इसके अलावा जहां तक when it come down to the Indian education system, typically engineering, in my opinion, we hardly get a chance there where we use our processor. So what is processor? Processor means brain. What अभी आप जिन लोगों के अच्छे खासे स्कोर है इंजीनियरिंग के, please go back and try to recall what you achieved there. So the people who can memorize maximum number of answers and people who can complete the paper in a 3 hours of time, you call it IO devices, isn't it? So memory में याद करो और 3 घंटे में पूरा पेपर खत्म करो. So people who are able to do that, they get the highest scores. And then people started believing. The biggest problem is that moment people by heart something, they start believing कि मेरे को समझ में आ गया है. That is what taught to us. I'm not saying you, even I am from the same Indian education system only, correct? So what I have seen that our 16 whatever 14 12 plus 10 plus 2 plus 4 16 years of education, people are teaching it that if you can memorize something, it means that you have understood it. So understanding and memorizing, इन दो वर्ड्स का डिफरेंस इंडियन लोगों को नहीं आता. दैट इज द बिगेस्ट प्रॉब्लम इन माय ओपिनियन. ऑब्वियसली मेरा अपना ओपिनियन है, आपका अलग हो सकता है. यू आर फ्री. आप लोग एनालाइज करो and then you ask the question to yourself whether you understand the things, whether you memorize the things. And I only request that don't do that for data structure. If you are doing it for data structure, that is your biggest mistake. With that, what you can do, you can only write the algorithms that you are written before. Moment you want to write a new algorithm, now you need understanding, you do not need the memory. I have always said that even though you forget some algorithm, that is still fine. Don't remember the algorithm. You forget some algorithm, that is fine, but you understand the way the algorithm is derived. And to not forget, you try it again and again on paper. I may not keep telling it for every algorithm like a first time, so I'm telling you, I'm repeating the whole algorithm once again for you. एंड प्लीज नोट दैट मैं आपको कोड लिख के, और एक चीज, हाँ एक और चीज, डेटा स्ट्रक्चर पढ़ने के दो तरीके होते हैं. एक तरीका होता है रेडीमेड कोड लो. दिस इज अ कोड, यू एक्सप्लेन इट लाइन बाय लाइन एंड यू से दैट ये लाइन है, इसका मीनिंग ये है, ये लाइन है, इसका मीनिंग ये है, ये लाइन है, इसका मीनिंग ये है. दिस इज वन वे ऑफ लर्निंग डेटा स्ट्रक्चर. The second way of learning data structure is that you do not come with the code, you do not start with the code, you start with the diagram, you start with the concept, and you draw the diagram, you build your own code. Build your own code. By the way, which method is better, the first or second? The second method is better. It is time taking, but it is worth. Always remember that. So when you come with the ready made code, you always say that. तो वहां पर आप लोग कोडिंग नहीं सीख रहे हो. You are not doing like your what is that, आप आपकी थिंकिंग एबिलिटी नहीं बढ़ा रहे हो. आप लोग क्या कर रहे हो, आप लोग आपकी एनालिसिस एबिलिटी बढ़ा रहे हो. कोडिंग एनालिसिस, अच्छा ये कोड ऐसे है, अच्छा ये कोड कैसे वर्क होता है. सो यू आर गोइंग मोर ऑफ अंडरस्टैंडिंग एग्जिस्टिंग कोड. यू आर नॉट गोइंग द डेटा स्ट्रक्चर और नॉट यू आर ट्राइंग टू बिल्ड द कोड. सो अगर आपको कोड डेवलपमेंट करना है, इंप्लीमेंटेशन करना है, रेडीमेड कोड को बाजू में रखो एंड यू कम अप विद दिस. लेट मी जस्ट टेल यू, मैंने जितना सारा डेटा स्ट्रक्चर पढ़ा है, यू आस्क मी सो व्हिच इज द बेस्ट बुक फॉर डेटा स्ट्रक्चर. वैसे किसी ने पूछा नहीं, वैसे लोगों को आदत होती है, बट देन व्हिच इज बेस्ट बुक फॉर डेटा स्ट्रक्चर. आई सेड आई हैव नेवर लर्न or read a single book in my life for the data structure. I'm telling you truth. I never read any book for the data structure. I definitely have got 2-3 books at my home, but I never read the entire book. और ये book पढ़ा और वहां से मैंने प्रोग्रामिंग किया, आज तक ऐसा मैंने कभी नहीं किया. तो सर आपने कैसे किया? I draw the diagram, I come up with my own code. अगर सर गलत हुआ तो कंप्यूटर एरर दे ही देता है. अगेन आई गो बैक टू द पेपर, अगेन आई डेवलप द कोड. तो probably the code that I'm developing over here, you may not ask and do not ask सर ये कौन से बुक से लिया गया है. Obviously when there will be like some difficult algorithm or some definitions are there, so इसको क्या कहते हैं उसको क्या कहते हैं, that is a place where you need a book for a data structure. आई रिपीट, सर नोड किसको कहते हैं? अब नोड किसको कहते हैं ये प्रोग्राम करके समझ में नहीं आएगा. हाँ, दैट स्टफ यू कैन ऑलवेज रीड इट फ्रॉम अ बुक, दैट इज एब्सोल्युटली फाइन. या लिंक लिस्ट में ट्री में रूट किसको कहते हैं, yes you can talk about. और या फिर हाइट किसको कहते हैं, लेवल किसको कहते हैं. नाउ व्हेन दिस काइंड ऑफ टर्मिनोलॉजीज कम्स, फॉर द टर्मिनोलॉजीज, फॉर द concepts, you might need a book. When it comes down to the program, all you need is a paper, pencil, your computer, and your brain. I'm very sure you have got all 4 things, so you can be ready to learn data structure. ये मुझको एक्चुअली कल ही बताना चाहिए था, लेकिन कोई बात नहीं. I'm going ahead and I'm starting once again from scratch. Please pay attention and do not ask me once again, sir ये trav is equal to null क्यों दिया और trav next is not equal to null क्यों दिया. Don't ask me. Do the paperwork for me if you want to understand it better. चलो go ahead, I'll start with. मुझको ये सारे नोड्स प्रिंट करने वन आफ्टर अनदर. सो मुझको प्रिंट क्या करना है, पहले तो मेरा आउटपुट क्लियर है. मुझको 11, 22, 33 आउटपुट का चाहिए. किसी भी एल्गोरिथम के लिए, किसी भी कोड के लिए, यू फर्स्ट शुड नो कि आपको आउटपुट क्या चाहिए. सो यू लुक एट द डायग्राम, मेरे को आउटपुट चाहिए 11, 22, 33. यू डिसाइडेड. अब फ्रॉम वेयर यू गेट द फर्स्ट वन? फर्स्ट वन दैट इज वेरी क्लियर. ए फर्स्ट वन इज नथिंग बट द हेड पॉइंटर. सो मुझको हेड से शुरुआत करना है, हेड से शुरुआत करना है, एंड देन आई वांट टू प्रिंट द डेटा ऑफ ईच नोड. So how do I begin with the head? Or to begin with the head, all we have, just a minute. Today is Thursday. 2 minute रुको. Am I audible? Okay. Let us continue further. So what I was saying is that you start with the first node. Yeah, I got the address of the first node. I got the address of the first node. Now I want to print that node. How do I print that node? So first of all, you get the address of the first node. So I say, let's say 100 is the address of the first node. I got the address of the first node. What I want to print? I want to basically print, Trav's data, trav.data. So this part I want to print. At this moment, trav is pointing to the first node and trav.data. So I'm trying to print this data. चलो पहला नोड तो प्रिंट हो गया. How do I go to the second node? How do I get the second node? How do I get the address of the second node? To get the address of the second node, a trav.data अगर 11 है, डायग्राम देख के मेरे को पता चल रहा है trav.next is nothing but 200, which is basically the address of the second node. If it is the address of the second node, how do I get it and how do I continue with this? So I simply say that take trav.next into trav. A trav.next is 200. Trav.next is 200. So you get 200 into this. Now the trav is no more pointing to this. Now trav started pointing to this. Okay. Is this good? Yes, this is good. You continue further. Now what you want to do? I want to repeat the process. A 11 is already printed. That is good. Let me again say printf trav.data. Again printf trav.data. Again I'm printing the data. Or data is like 22. No problem. A 22 is printed. Again I want to go to the next node. Let's say 300. 300. So 300 over here will be copied into the trav. And if 300 is copied into the trav, ultimately it is pointing to this. Okay, it is pointing to this. Now again, now please tell, आपको repeat करना है process? Should I ये वापस से करना है? मतलब 11, 22 is printed. एक और iteration चाहिए इस loop का या नहीं चाहिए? Do you want one more iteration? हेलो, अरे मैं पूछ रहा हूँ लूप का इटरेशन चाहिए क्या? द लूप इटरेशन, द लूप इटरेशन इज रिक्वायर्ड. हैव अ लुक एट दिस. अभी तक 33 इज नॉट येट प्रिंटेड. Please note, 33 is not yet printed. As earlier Naneshwar was saying, or like some more few people are saying that कि सर वो जो 30, अगर आप लोग वो कंडीशन लिखते हो trav dot next, right now you find that trav dot next यहीं पर null हो रहा है. और अगर trav dot next not equal to null, अगर मैं ये वाला कंडीशन लिखूंगा क्या हो जाएगा? The last node will never get printed. The last node will never get printed. Please understand that. So what I'm saying, you continue further. I want one more iteration. I want one more iteration. So let me repeat this one more time. Let me print 33 over there. Let me go ahead and say that trav is equal to trav dot next. Yeah, abhi trav dot next क्या है? Abhi trav dot next is null. Abhi trav dot next is null. So in this case, it will just point to 0. That's it. And now tell me, क्या ये loop फिर से एक बार रिपीट करना चाहिए? क्या ये लूप फिर से एक बार और एक इटरेशन करना चाहिए? नहीं करना चाहिए. क्यों? क्योंकि जो हमारा इनिशियल गोल था 11, 22, 33 प्रिंट करने का, वो गोल हमारा ऑलरेडी कंप्लीट हो चुका है. और अगर हमारा गोल कंप्लीट हुआ है, देयर इज नो पॉइंट इन रिपीटिंग इट वंस अगेन. एंड दैट इज द रीजन. तो मैं अभी कहां पर रुक रहा हूं? व्हेन आई एम स्टॉपिंग द लूप, आई एम स्टॉपिंग द लूप व्हेन माय ट्रैव इज बिकमिंग नल. सो you go ahead and you develop a condition trav is not equal to null. I know that it is very stupid that a simple say code ke liye we are spending half an hour, right? But still, because the same sort of conditions will come again and again and every time. So every time, please sit with that. You do the paperwork and then you come up with the condition. Do not by heart कि यहाँ पर ये condition होता है, यहाँ पर ये condition होता है. यहाँ पर मुझको क्या condition देना था? मुझको सारे नोड प्रिंट होने के बाद में रुकना था. सारे नोड प्रिंट हो गए, ये कैसे पता चलता? When I am reaching to the null. हाँ, कभी अगर आपको इन फ्यूचर आपको ऐसी जरूरत पड़ती है कि आई वांट टू गो टू द लास्ट नोड, आई डू नॉट वांट टू फिनिश ऑल द नोड्स, बट आई वांट टू गो टू द लास्ट नोड. इफ यू एट ऑल वांट टू गो टू द लास्ट नोड, if you at all want to go to the last node, probably your condition will be trav dot next is not equal to null. Because the last node कौन सा होता है? Last node वो होता है जिसके next में null होता है. करेक्ट? सो जब आपको लास्ट नोड पे जाके रुकना है, एट दैट टाइम trav dot next is not equal to null. Trav not equal to null, where you want to go through all the nodes. I hope this is clear to everyone. Really sorry, ये इतना stretch नहीं करना था, but still I do not want to stretch the same thing again and again. So it is worth you learn it once in a while, and then you write in a code. A while node is equal to trav, trav is equal to head. That is good. And then while trav is not equal to null, a trav is not equal to null, printf, a printf यहाँ पर printf नहीं है, यहाँ पर system dot println है. क्या फर्क पड़ता है? You want to print trav dot data and you want to go to the next node. Trav is equal to trav dot next. That's it. Over. I just want to put one, let's say, list so that I can print it well. That's it, nothing else. I'm just showing that the data in a proper order. But by the way, at this moment, अभी तो मैंने assume किया था कि मेरा लिंक लिस्ट के अंदर 3 नोड है. What if अगर मेरी लिंक लिस्ट empty होती तो? अगर मेरी लिंक लिस्ट empty होती तो हेड के अंदर क्या होता? अगर मेरी लिंक लिस्ट empty होती तो हेड के अंदर क्या होता? वो हेड के अंदर नल होता. और अगर हेड के अंदर नल होता तो फिर इन दिस केस क्या ये कोड वर्क होता? क्या कोड वर्क होता? चेक करते हैं, चेक करते हैं. नहीं वर्क होता मतलब, एक मिनट रुको जरा. वर्क होता मतलब क्या? विल इट गिव एरर? नॉट रियली गिव एरर. इट विल प्रिंट प्रोबेबली लिस्ट. ए नोड इज इक्वल टू ट्रैव, ए ट्रैव इज इक्वल टू हेड, ए ट्रैव इज नल इन दिस केस. सिंस ट्रैव इज नल ओवर हेयर, while trav is not equal to null, a while trav is not equal to null, condition is false. A trav is already null, पहले इसमें condition false हो गया, and then you come out of the loop. In short, in this particular case, if linked list is empty, nothing will be displayed. When linked list is empty, nothing will be displayed. And that is what right now you should be able to see in your linked list. Right click, run as Java application, And if I run it as a Java application, let me take the input from the user saying that a choice is one, and what it shows? Oh, it shows me that my linked list is empty linked list. There is nothing to print in that linked list. Nothing to print in that linked list. That's it. Nothing much to do. This is all about my simple display function. Okay, now once my display function is there, I believe both time pass ho chuka hai. Now we will go ahead and we will start writing the rest of the functionalities one by one. If the display is clear, let us think of how do we create a new node and how do we add the node. तो सर कौन सा? अब अपने पास ऐड करने के प्रोबेबली तीन डिफरेंट ऑप्शंस हैं. एक तो वी वांट टू ऐड एट द बिगिनिंग, we might want to add at the end, we might want to add at the given position. वो three possible options are there. So कौन सा पढ़ेंगे? Let us learn all one by one. Let me begin with the function add last. What is add last? I want to create a new node, and the new node created, I want to put it at the end of the list. So how do we proceed with this? Again, always first draw the diagram. See the process? First draw the diagram, make yourself comfortable, understand on paper कि आपको क्या क्या चेंज करना है और कैसे कैसे चेंज करना है. Once you understood that, then you think of how do you write it in a code. The very first step, I'm telling you the process. Okay, so very first step, what to do? Go ahead and you draw this. Very first step is obviously I want to create a node. And to create a node, definitely the node will have some address. A node will have some address, and then you will have some data there, and you might have null at the end. So that is very simple. ये जो नया node है, this new node, we want to keep its address somewhere. Let's say that I'm keeping its address in a variable, let's say new node variable. So नया node है, you need to allocate the memory, you need to get it address. This will be obviously the first step. But after that, take a look at the diagram and tell me, जब मैं कहूंगा कि इस नोड को एट द एंड ऐड करना है, तो ये एड्रेस 400 मुझको कहां पर रखना चाहिए? Where that 400 should be kept? Where that 400 should be kept? हम लोग एड लास्ट की बात कर रहे हैं. एड लास्ट की बात कर रहे हैं. सो 33 का जो नोड है, जो लास्ट नोड है, उस लास्ट नोड के नेक्स्ट में if I keep it 400, then I can say that it is added at the end. Is this correct? Is this correct? Exactly. This is what I want to do. So finally पहले डायग्राम ड्रॉ करके ये समझो कि आपको करना क्या है. अब अगला क्वेश्चन ये है, so which node that you want to modify ultimately? Or the node that I want to modify over here is this part. इस जो लास्ट नोड है, इस नोड का नेक्स्ट. The question is, do you have pointer to that node? Do you have pointer to that node? I said, yes, I have got a pointer to this node, but not directly. The pointer to this node is kept in a previous of that. या इस नोड के नेक्स्ट में इसका पॉइंटर है. बट अगेन द क्वेश्चन इज, डू यू हैव एड्रेस ऑफ दिस नोड और नॉट रियली? आई हैव गॉट एड्रेस ऑफ दिस नोड इनडायरेक्टली इन एड्रेस ऑफ द प्रीवियस. व्हाट एग्जैक्टली इट मींस, अगर आपको ये मॉडिफाई करना है तो आपको इसका पॉइंटर चाहिए. बट द फर्स्ट क्वेश्चन इज दैट हाउ डू आई गेट द पॉइंटर टू दैट नोड? There is no option. You need to traverse all the way from the first node till the last node. I need to traverse from all the way from the first node till the last node. Please note, अब मुझको last node के आगे नहीं जाना है, मुझको last node के ऊपर जाना है. I want to go to the last node. By the which node you call it last node? Last node कौन सा होता है? अरे लास्ट नोड कौन सा होता है? लास्ट नोड वो होता है जिसका नेक्स्ट नल होता है. लास्ट नोड वो होता है जिसका नेक्स्ट नल होता है. प्लीज अंडरस्टैंड व्हाट यू आर सेइंग, राइट? एंड देन इफ यू अंडरस्टैंड दैट, so you understand the process very simple. So what are the steps? Steps are like this. Step number 1, create new node and initialize it. This should be like my first step. I understand that. What should be the second step? Traverse till last node. I'm not saying that traverse all the nodes. I'm saying traverse till last node. Traverse till last node. And then what is the last step? Add new node into next of last node. That's it. It is a 3-step process to be followed when you want to do add last. Sir, कोड कैसे लिखेंगे? हाँ, कोड कैसे लिखेंगे? That is very simple. I hope you are getting the point. पहले डायग्राम ड्रॉ करो, समझो आपको क्या आउटपुट चाहिए. Step number 2, write in a plain English what exactly you are trying to do. And once you understood that, then think of इसको कोड में कैसे कन्वर्ट करेंगे one after another. Let us get started. A very first thing, create a new node and initialize it. Oh, create a new node and initialize it. That should be very simple line. New node is equal to new node and whatever value that you want to initialize, probably 44 in our case in this diagram. So that value you pass it and you initialize the node. A constructor will take care of initialization. The first job is done. Second job, you want to traverse till the last node. How do I traverse till the last node? Already we spent a long time in traversing, so you understand it very well. So you start from the first node. You start from the first node and all the way you want to go till the last node. So trav dot next is not equal to null. Simply say trav is equal to trav dot next. What happened? Yes, I go till the last node. So again, do the paperwork. Do not by heart that. Do the paperwork. Over here, you started with trav is equal to head. A trav is equal to head, so trav is equal to 100. क्या इसका next null है क्या? अरे इसका next null है क्या? इसका next null है? नहीं है. So you say trav is equal to trav dot next. So you go to the next node. You go to the next node. इसका next null है क्या? इसका next null है क्या? नहीं, इसका भी next null नहीं है. You go to the next node. And I guess initially you have seen that यहाँ पर 0 था. हाँ, in this particular case, do you see that इसका next null है क्या? इसका next null है क्या? Yes, obviously इसका next null है. So this is where I want to wait. This is where I want to do. Okay, I understood that. And now I got the pointer to this. So I can say that trav is at this moment pointing to this. What is the last step? The last step is that add the node into the next. So आपका ये जो new node है 400, ये 400 ये जो एड्रेस है, ये एड्रेस आपको यहाँ पर राइट करना है trav के next में. So it is hardly a line of a code. Simply say that trav dot next is equal to new node. Trav dot next is equal to new node. That's it, nothing else to be done. Let us just quickly go ahead. Let us just go ahead and try to type this much of code. Please note, this code is not yet completed. This code is not yet completed, but at least this will give you a bit confidence. जो हम लोग ने वहां पर लिखा है, यहाँ पर कैसे लिखेंगे? वैसे लिखेंगे. So you simply say that new node. Please note initialization. यहाँ पर हम लोग सिर्फ memory allocate कर रहे हैं. Initialization is taken care into the constructor. Initialization will be taken care into the constructor. You continue further. What is the first step? Create new node and initialize it. Next step, traverse till last node. How do you traverse till last node? You start with the first node. And then all the way, while trav dot next is not equal to null, simply say trav is equal to trav dot next. This is done. And then what is the third step? Add the node, add new node after trav, or rather into, it's after trav in the sense simply saying that trav's next, right? So all you are writing is that trav dot next is equal to new node. So I'm saying that it is hardly simple code that we write. It is not number of lines that we write. The way we build the code, that is important. Chalo, we have built the code. What is the next job to be done? So you say that, sir, go ahead and run it. No, never. Linked list में rule हमेशा याद रखना. First, you write a generic case. You ensure that this is correct. And now you start thinking of the special cases. special conditions, कि in which conditions your code might fail. You also call them as a corner cases or special cases. And you find that initially this code is good, this code will work, no doubt on that, but the initial condition or a special condition जहां पर हमारी लिंक लिस्ट एम्प्टी होगी, initially our linked list is empty. If our linked list is empty, please pay attention. If our linked list is empty, now what will happen? In this case, the head itself is null. Now think of it, will this code work correctly? Again, do not say directly no. Go do the paperwork. Do the paperwork and try to understand at which line this code may fail. अगर फेल होने वाला है तो कुछ करेंगे, अगर फेल नहीं होने वाला है तो then this code, if it is working, nothing to write specially, right? So you go ahead, you write the first line. A first line is that node new node is equal to new node. इसमें कोई प्रॉब्लम है क्या? So इसमें कोई प्रॉब्लम नहीं है. दूसरा, node trav is equal to head. A trav is equal to null. Null अगर आप लोग head में sorry trav में डाल रहे हो, null अगर हम लोग trav में डाल रहे हैं, is there any problem? No, there is still no problem. प्रॉब्लम कब होगा? प्रॉब्लम तब होगा जब मैं कह रहा हूं trav dot next is not equal to null. अरे problem is that you are trying to traverse till last node, but the linked list is empty. There is nothing in a list. If there is nothing in a list, you try to traverse, it is giving you the null pointer exception at this line. I'm very sure null pointer exception आप लोगों ने बहुत बार देखा है. अरे अगर आपने जावा पढ़ा है, नल पॉइंट एक्सेप्शन हमने बहुत बार देखा है, बहुत बार देखा है. ट्रस्ट मी, इवन दो यू आर 10 years एक्सपीरियंस इन जावा, दिस इज द एक्सेप्शन दैट यू सी द मैक्सिमम टाइम. So don't worry about it. So coming back to the point, I'm saying that in this case, चलो सर I understood कि ये कोड, एक मिनट, इससे मेरे को क्या समझ में आया? मुझको इससे ये समझ में आया, ये वाला कोड इस स्पेशल केस में नहीं चलता. ओके, नहीं चलता. अब अगला क्वेश्चन, तो सर ऐसे केस में क्या होना चाहिए? What should be done in this case? इस केस में क्या होना चाहिए? अगेन, कंडीशन क्या चेक करना है मेरा क्वेश्चन नहीं है. मेरा कंडीशन ये मेरा क्वेश्चन नहीं है. मेरा क्वेश्चन ये है कि इस कंडीशन में करना क्या चाहिए, डायग्राम में क्या चेंज होना चाहिए. इफ दिस इज माय फर्स्ट नोड, लेट्स से 44 इटसेल्फ इज माय फर्स्ट नोड, तो ऐसे केस में क्या करना चाहिए? टेल मी इन इंग्लिश. डोंट ट्राई टू राइट अ कोड. यू ट्राई टू राइट अ कोड एंड देन यू पीपल मेक द मिस्टेक. आई एम सेइंग दैट सिंपल प्लेन इंग्लिश. माय क्वेश्चन इज दैट ऐसे केस में क्या करना चाहिए? ऐसे केस में ये जो नया नोड है, दैट इटसेल्फ इज योर फर्स्ट नोड. हेलो, एम आई करेक्ट? दिस नोड इटसेल्फ इज अ फर्स्ट नोड. And if you are saying that if this node is itself is the first node, what you need to do it diagrammatically. Diagrammatically क्या होना चाहिए? ये मेरा न्यू नोड है जिसके अंदर एड्रेस है 400. Diagrammatically क्या होना चाहिए? Nothing much. I need to just keep this address into the head so that this node becomes the first node. Is it very simple? That's it. मैं हमेशा ये कहता हूं कि पहले वो लोग डायग्राम में ठीक करो. लोग क्या कर रहे हैं, अभी आपने ऊपर भी बहुत सारे लोगों ने आंसर दिए थे, डायरेक्टली कोड लिखना चालू कर दिया था. और ट्रस्ट मी, जितने कोड लिखे थे, मैंने पढ़े सारे कोड, जितने कोड लिखे थे उसमें से सारे के सारे कोड गलत थे. ऐसा क्यों होता है? सी, यू पीपल अंडरस्टैंड लॉजिक, but you directly try to convert into the Java language or C language, so there are likely chances that you are making a mistake. I said that whatever you are understanding, first put it in diagram, then put it in English, and then put it in Java. If you go step by step process, trust me, it will be a easy job. अब बोलोगे सर इसमें बहुत टाइम जाएगा. हाँ, मेरे को पता है इसमें बहुत टाइम जाएगा, बट वैसे भी टाइम बचा के आपको जाना कहां पर है? आई होप द क्वेश्चन इज वेरी सिंपल. और जिंदगी में कभी ना कभी एक बार लिंक लिस्ट ठीक से पढ़ लेना चाहिए. अब आप लोग इतने सालों से जो अपने पढ़ना चाहिए था, लाइक आई एम वेरी श्योर आइडियली नाउ पीपल हु कम डाउन फॉर दिस ब्लॉक कोर्स, सीकेट एग्जाम में ऑलरेडी लिंक लिस्ट था, तो आइडियली अपने तभी पढ़ लेना चाहिए था. वी शुड नॉट हैव वेस्टेड अवर टाइम ओवर हियर. लेकिन वहां पर नहीं पढ़ा है, इसलिए अभी भी कंफ्यूज है. सो अभी भी कंफ्यूज है, अभी भी कंफ्यूज रहोगे, आगे जाके और कंफ्यूजन आएगा. कभी फिर कंपनी के कैंपस में जाओगे, वहां पर कंफ्यूजन रहेगा. सो यू नो, सम टाइम सूनर और लेटर एक बार जिंदगी में पढ़ लेना चाहिए. सर एक ही बार पढ़ना है, एक बार पढ़ना काफी हो जाता है, बट एक बार सही ढंग से पढ़ना चाहिए. नॉट बाय हाइटिंग द कोड और नॉट डायरेक्टली. मैं फिर से बता रहा हूं, देयर आर 3 स्टेप्स. जो कुछ भी आपको करना है पहले डायग्राम ड्रॉ करो, उसको इंग्लिश में लिखो, और इंग्लिश में लिखने के बाद में फिर उसको कोड में कन्वर्ट करो। बाय द वे इट इज स्पेशल केस, तो आपकी जो स्पेशल केस है, आपकी जो स्पेशल केस है, हाउ डू यू कंसिडर दिस स्पेशल केस? आई कंसिडर द स्पेशल केस समथिंग लाइक दिस: इफ head is equal to null. I understand that it is a linked list is empty. This is my special case. And in this special case, all I need to do is that head is equal to new node. If this address I want to copy into this, nothing else I need to do it. Am I correct? Is this all right? Yes, head contains the address of a new node. Nothing else is to be done. That easy. So you go back and you write it in a code. So obviously you want to always create the first node, no doubt on that. Now you check the special case. You check the special case. So I will call it, let's say, special case 1. And the special case 1, if list is empty, करना क्या है? Make new node as first node of list. Make new node as a first node of a list. Write in English. If you're written in English, then you go ahead. And then what you need to do, say if head is equal to null, you understand that your list is empty. If list is empty, what is to be done? Head is equal to new node. Okay, that is good. Else, what is else? Like a general case. And what is general case? The general case where you simply say that add a node at the end. But to add the node at the end, it is a two-step process. You need to first traverse till the last node, and you need to add the node over there. Oh, that's it. So is it done? This is absolutely done. And if it is absolutely done, you need to just call it from the main. So I guess वो आप लोग कर लोगे. So go ahead and we, yeah. So I'm just going back. तो सर इसको कॉल कैसे करेंगे? ए गो अहेड, एड फर्स्ट, एड लास्ट, जो भी आपका केस है. सो लेट मी जस्ट टेक सम वैल्यू फ्रॉम द यूजर. Let me take some value from the user, and let me just ask user, what is that? Enter new element. Okay, done. Enter new element. Take the input. Value is equal to sc dot next int. You have taken it from the user. Simply say list dot add last. You pass that to the value, and you are done. It's my add last code. Run that code. Check it if it is working. Go ahead. हाँ, क्या क्या कंडीशंस है? ए पहले डिस्प्ले you find that my linked list is empty linked list. It is empty linked list. There is nothing in a linked list. Let me go ahead, add the node. कहाँ पर है? Add last. Let me add the node. Let's say 33. I added the node 33. Again, I'm saying display. This was my special case. My list is having only 33. You continue further. Again, you say that adding the last, let's say 22. 33 के बाद में मैंने 22 ऐड किया है. So please note, 33 के बाद में 22 ऐड किया है. Oh, this is working. And again you continue further. Again you say, let's say 11, and you find that display once again 33 के बाद में 22 के बाद में 11, and everything is working well. I hope you are getting the same results. Please check if it is going well for you. मैंने कोड ऑलरेडी कॉपी कर दिया है, और कोड ऑलरेडी आपके कोड शेयरिंग के ऊपर चल ही रहा होगा. जिसका कोड शेयरिंग के ऊपर नहीं चल रहा है, टेक इट फ्रॉम हेयर. what we are talking about was like, hey, we have got like a special node, a special case. What a special case? If list is empty, whatever new node is created, that node, it should be a first node. So we simply say head is equal to new node. So there is nothing great into that. But if already there are few nodes in the list, if there are already few nodes in a list, what all I need to do? I need to first traverse till the last node. How do you traverse till the last node? You start with trav is equal to head, while trav dot next is not equal to null, trav is equal to trav dot next. What this will do? This will take you all the way from first node till the last node. You are starting trav, ये पहले हम लोग यहाँ से हेड से शुरू कर रहे हैं, हेड से शुरू कर रहे हैं 100, इसका नेक्स्ट नल नहीं है, वी आर सेइंग trav is equal to trav dot next. इसका नेक्स्ट 300 है, इसका नेक्स्ट भी नल नहीं है, we say trav is equal to trav dot next. And initially you find that if this node was, इसका नेक्स्ट नल है, इसका नेक्स्ट नल है, it only means that ये जो नोड है it is the last node. Oh, I understand, this node is the last node. If this node is last node, अब क्या करना है? ये जो आप लोगों ने नया नोड क्रिएट किया है, इसका जो एड्रेस है, इसका जो एड्रेस है, this address I want to put it, this address I want to put it over here, so that the last node, the already जो old last node होगा, that will start pointing to this. So how do I do that? ये मेरा trav है, ये trav का next है. So trav's next is equal to new node. Trav's next is equal to new node. That's it. I hope, Amit, that is fine. That is what last line is written over here. Else part ka end. Trav dot next is equal to new node. If this is done, we can go ahead and we can talk about the next function, add first function. Now you see that we took very long time to learn the first one. Yes, correct. Last node reference is equal to last node's next is equal to new node address. Absolutely correct. Display took a very long time. Add last took relatively less time. Let's see how it goes with the add first function. Add first function, and again the same technique we will follow once again. What is add first technique? We want to add a node at the beginning. You want to add a node at the beginning. A very first step that you should try. What very first step? You first ask a question to yourself. You first ask the question to yourself कि क्या होना चाहिए? Diagrammatically क्या होना चाहिए? That should be like your very first question. चलो देखते हैं diagrammatically क्या होना चाहिए. So diagrammatically क्या होना चाहिए? Diagrammatically आपने एक नया नोड क्रिएट करना चाहिए. Oh yes, I need to create a new node. I need to create a new node. I need to initialize the node. Okay, that is good. I need to initialize the node. Whatever address is there, you can collect it in some pointer. Yeah, I collected a pointer, let's say 400. Okay, that is good. I have done that. What is the next step? What is the next step? Diagrammatically, again, please don't tell me the code. Please don't tell me the code. Look at the diagram and then what should happen? How you can say that this is the first node? Yes, people are saying that ultimately head should point to this node. But look at the diagram. Just by making head pointing to the first node, will it solve the problem? Look at the diagram. Head become 400. What will happen? If head become 400, then the linked list will have only the one node. A linked list will have only the one node. Okay, sorry, that is the problem. So what I should do? I should not first bother about this. First of all, I should say that अभी जो मेरा current first node है, अभी जो मेरा current first node है, क्या होना चाहिए? This one is 100. It should point to this. Am I correct? This should, जो नया node है उसके next में मेरा current head जो है 100 जो है वो पहले ऐड होना चाहिए. That should be first step. And after you done that, then your next step should be the 400 pointing and head pointing to this. So definitely you need to do it as a two-step process. You need to do a two-step process, rather three-step process. Which three steps process? The step number one, you need to first allocate the node and initialize it. What is step number two? जो नया node का next है, it should point to your current head or the first node. उसका next current head को point करना चाहिए. और फिर तीसरा step है, head should point to the new node. Head should point to the new node. And let us just write it in English ये डायग्राम में क्या करना है वो मेरे को समझ में आ गया. लेट मी राइट इट इन इंग्लिश. फर्स्ट स्टेप, allocate and initialize new node. Step number 1. What is step number 2? Step number 2, I'm saying it should be new node next should first node address. Okay. And third step, what we are saying? What is third step? The head should be new node. Head should point to the new node. That's it. And these are the 3 steps. Let us just go ahead, convert it into the Java language. Let us convert it to Java language. Allocate and initialize the new node. Okay, allocate and initialize the new node we are good at. A new node is equal to new node. We pass the value, constructor will take care of initialization. What is second? New node next should first node address. So you are saying that new nodes next, इसकी बात चल रही है, यहाँ पर 100 आना चाहिए, ये काम चल रहा है. So new node next is equal to the first node address. A first node address, you already know that a first node address already head में होगा. तो जो head में address है, that address you collected over there. That is probably your second step. And third step, you are simply saying that head should point to the new node. It should point to the new node. So new node address is, let's say, 400. So it should point to this. So new node का address कहाँ पर है मेरे पास? और मेरे पास new node का address है यहाँ पर, new node pointer के अंदर. So just go there and simply say head is equal to new node. So is 3 lines of code is sufficient? More than sufficient. Is 3 lines of code is sufficient? More than sufficient. Nothing else. माधुरी आप फिर से गलत लिख रहे हो. आपको माधुरी आपको हेड में क्या चाहिए? आपको हेड में क्या चाहिए? नए नोड का एड्रेस चाहिए. ड्रॉ द डायग्राम. यू सी दैट ए नए नोड का एड्रेस क्या है? 400. वेयर 400 इज? लुक एट द डायग्राम. वेयर 400 इज? ओ 400 इज इनटू द न्यू नोड. Where 400 is? A 400 is into the new node. So whatever address is there into the new node, whatever address is there into the new node, that address I want to copy into the head. I hope now it is clear. Not new node dot next. हेड के अंदर 400 आना चाहिए. ये 400 मुझको कहां पर मिल रहा है? न्यू नोड के अंदर मिल रहा है. न्यू नोड नेक्स्ट के अंदर नहीं मिल रहा है. न्यू नोड नेक्स्ट विल बी इनिशियली नल. इज दैट ओके? मैं फिर से एक बार डायग्राम ड्रॉ कर रहा हूं और हम लोग फिर से एक बार चेक करेंगे हाउ एग्जैक्टली इट शुड गो. मैं फिर से एक बार डायग्राम ड्रॉ कर रहा हूं. प्लीज पे अटेंशन. हाँ, ऑल राइट. आई एम गोइंग अहेड. व्हाट इज टू बी डन? व्हाट इज द वेरी फर्स्ट स्टेप? वेरी फर्स्ट स्टेप, एक कोड अभी आपके सामने लिखा हुआ है. वेरी फर्स्ट स्टेप, allocate the node. Allocate the node. Let's say 400 some address 44, it is data available, and this address I'm taking in a pointer new node. This is like a node is allocated with the next. a by default उसका next null होगा. हमने कंस्ट्रक्टर में उसको null किया है, आप लोग चेक कर सकते हो. This is done. The first step is done. What is second step? The second step is that new node का next कहाँ पर point होना चाहिए? A new node का next हेड को, मतलब पहले नोड को पॉइंट होना चाहिए. लेकिन वेयर इज द फर्स्ट नोड एड्रेस? ए फर्स्ट नोड एड्रेस इज 100 एंड दिस एड्रेस is already given into the head. So whatever the address inside head, the same address I need in a new node next. Whatever the address inside head, the same address I should take it over here. What will happen? This 100 that you are able to see it over here, it has to be copied into this. That is the second step. मैं एक एक लाइन विथ डायग्राम दिखा रहा हूं. What is the third step? The third step is that अब this is pointing to this. इसमें कोई प्रॉब्लम नहीं है. But linked list has to be always start from a first node, and head node should always contain the address of the first node. अब आपका पहला जो नोड था वो चेंज हो गया है. You have got like a new node. So you simply say that head is equal to new node. Head is equal to new node. Now what will happen? Head is equal to new node. Now what will happen? This head ए न्यू नोड का अंदर का एड्रेस कितना है 400. दिस 400 एड्रेस यू आर कॉपिंग ओवर हेयर. सो आई एम सेइंग दिस विल स्टार्ट पॉइंटिंग टू दिस. तो अब मेरी लिंक लिस्ट कैसे चलेगी? हैव लुक एट दिस. अब मेरी लिंक लिस्ट हेड से शुरू होगी. फ्रॉम हेयर इट इज गोइंग टू दिस, इट विल प्रिंट दिस, then it is going to this, it will print this, then it will going to this, it will print this, it will going to this, it will print this. उसके बाद में वैसे भी it is null, null, so you need to stop there. Is this clear? Good. And if this is clear, so again you can just go back and type it. But before that, sir, is there any special condition? Is there any special condition? Again, we will consider the case. Amit is asking the question, is it allowed to have sequence of node like 400, 100, 200, 300? Amit, these are just the addresses and these are just the example addresses. In real world, जब आप लोग प्रोग्रामिंग करोगे, जब रियल वर्ल्ड आप लोग प्रोग्रामिंग करोगे, एड्रेसेस आपके हाथ में नहीं होते. एड्रेसेस आर गिवन बाय द जेवीएम एट रन टाइम. नाइदर यू कैन सी दोज एड्रेसेस. ये तो कुछ तो नंबर चाहिए ताकि हम लोग विजुअलाइज कर सके. तो इसके बाद में भी लोग कंफ्यूज होते हैं. अगर विजुअलाइज नहीं करोगे तो कितना हालत खराब हो जाएगा. यू कैन इमेजिन. एनीवे, ए वी हैव गॉट लाइक अ हेड एंड इनिशियली हेड इज इक्वल टू नल. नाउ टेल मी, इन दिस पर्टिकुलर केस क्या ये कोड चलेगा? क्या ये कोड चलेगा? लेट अस गो स्टेप बाय स्टेप. अपनी अकल नहीं लगाना. अगेन प्रणव वेट, प्रणव शैलजा वेट. कोड चलेगा नहीं चलेगा अपनी अकल मत लगाना. गो अहेड, डू इट. कोड करके देखो, डू द पेपर वर्क. और बाद में पेपर वर्क के बाद में सोचना कि कोड चलेगा या नहीं चलेगा. आई होप यू पीपल आर गेटिंग माय पॉइंट. आई एम जस्ट गोइंग अहेड. सो व्हाट इज द फर्स्ट स्टेप? व्हाट इज फर्स्ट स्टेप? allocate the node. allocate the node. So new node, एड्रेस कुछ भी हो सकता है. लेट्स से 400, लेट्स से 40, नेक्स्ट इज नल एंड इट इज पॉइंटिंग. दिस इज डन. What is second step? What is second step? New nodes next is equal to head. ये चेक करो. in new nodes next you are talking about this. ये क्या होना चाहिए? head. ये head क्या है? अभी null ही तो है. so this will be null only. अरे ये null ही रहेगा, इसमें कोई change नहीं होगा. इसमें null ही रहेगा, इसमें कोई change नहीं होगा. that is fine. What is the next step? The next step, you are saying head is equal to new node. What is the address in new node? Address in new node is 400. So this 400, it is pointing to this. It is pointing to this. Just tell me, this is what should happen. अरे यही होना चाहिए, कुछ और भी होना चाहिए था. If your linked list is empty, यही होना चाहिए था. If यही होना चाहिए था, it only means that this code is working. इसलिए मैं कहता हूं कि रट्टा मत मारो. आई रिपीट वंस अगेन, रट्टा मत मारो. कि ऐसा कभी मत कहना कि सर ये कोड नहीं चलता है. डायग्राम ड्रॉ करो, नहीं चला फिर सोचना कि इसके ऊपर क्या करना चाहिए. लेकिन सर अगर वो कोड चल गया तो चल गया, तो रहने दो ना. व्हाई आर यू अननेसेसरी राइटिंग अ न्यू कोड? करेक्ट. गो अहेड. एट फर्स्ट create new node and initialize it. Okay, that is good. Now what is next step? Next step, what is that? Address new node next should point to head, the current first node, and then head should point to new node. You continue further, you simply say that new node is equal to new node, you pass the value. The first step is done. Second step, what is that? New node dot next is equal to head. Okay, that is good. And a third one, head is equal to new node. This is done. Over. Finish. Absolutely finish. So will it work? कॉल करके देखो. अब ये ज्यादा आसान है. एटला जैसे कॉल किया था, कॉपी and paste. Instead of add last, I just want to say it is add first. Instead of add last, I just want to say it is add first, and no other changes are really needed. So now will it work? Yes, ideally it should work. Why don't you try that? Let me just try to run this Let me check this if it is working. So initially there is nothing in a linked list. Let me try to add a node. Add first I'm trying to add, let's say 30. मैंने 30 ऐड किया. एक और let's say add 20. मैंने 20 ऐड किया. You see मैंने कुछ गलत एंट्री किया क्या? Sorry, first display. हाँ, second new node, let's say 20. And you see that a 20 is added before 30. Okay, that is good. 20 is added before 30. Again you say add first. Again I'm saying 10. You find that 10 is added even before that. You see that there is absolutely no problem. Even पहले node को भी कोई problem नहीं आया. Let me simply go ahead. तो सर एडलास भी चलता है, चला के देखो. Let's say I'm adding 40 को मैंने एडलास किया. ये पहले मैंने 30 ऐड किया था, 30 के पहले 20 ऐड किया, 20 के पहले 10 ऐड किया और बाद में एडलास्ट 40 किया है. एडलास्ट 40 किया है. You check, oh 40 is added at the end. Look like everything is working well. Check if it is working at your end as well. And if it is working at your end as well, we will take a break for 10 minutes. And after the break, we will talk about the rest of the functions. So please revise, do paperwork. Any questions are there, let me know. I hope you're there. Let us just get back to the code and what we have seen so far. A quick recap. What we are trying to write is a linked list. We are trying to write a linked list. To make a linked list, we say that linked list is list of nodes. It is a list of, it is a, the list of nodes, they are linked together. But to have a list of nodes linked together or list of items linked together, so we have written a kind of a linked list. But to represent each node, we have written a class called as a class node. What class node contains? Each node contains only two parts. One is the data and a pointer to the next node. It contains a data and a pointer to the next node. That's it. Nothing else it contains. And basic initialization job is done. Not anything apart from that. Making it as a static member class of it, advantage is I can directly access its private member in the outer class. Why it is made as a static member class? So that I can access its private members directly over here. अगर आप लोग वो नहीं करते, if it is not done as a static member class, what is the problem? हर बार आपको get next, set data, get data, this kind of code करना पड़ता. So I just thought that better I make it inside this. Otherwise इसके अंदर कुछ भी special नहीं है. The node class is like super simple class. All it is representing is one node. All it is representing is one node in a linked list where you have got some data and where you have got like a pointer to the next type, pointer to the next. Rather, this node next is a pointer of the same type. Next is a pointer of the same type. It is also, people call it as a self-referential class. This is a terminology. People call it a self-referential class. What is self-referential? A pointer, a class contains pointer of the same type. Pointer of the same type. Node class we have created, and then we went for like a head, because linked list you do not store the whole thing. You store only the address of the first node, and the first node will have address of the second. Second node will have address of a third, and third will have address of fourth. That's it. Initially, when you begin, the linked list is initially null, and you start with this. To display the linked list, the logic was you begin from the first node, until you traverse all the nodes. For each node, you print the data and then go to the next node. Print the data, go to the next node. Print the data, go to the next node. कब तक? जब तक आप लोग लास्ट नोड तक नहीं पहुंच जाते तब तक. So you talk about like a display method. Once it is done, you continue further. We have got the function, let's say add first. We are trying to add a new node at the beginning. To add a new node at the beginning, so you create a new node. वो जो नया नोड है उसके नेक्स्ट में आपका जो ओल्ड हेड होगा, जो करंट हेड होगा, उसको पॉइंट करवाओ, एंड देन यू सिंपली से head is equal to new node. That's it. So add first is done. And then what is add last? Now for add last, you see that if the linked list is empty at the moment, if the linked list is empty, the first node itself is your new node. Otherwise, you can traverse till last node. You can traverse till last node and add new node address into that last node next. So only this much of code that we have written. Ekansh, I have done the whole revision for you, not only the node class. Right? I hope now it is comfortable for. And then we can go a step ahead. Now we can go a step ahead, and then we say added position. तो एडेड पोजीशन मतलब क्या? एडेड पोजीशन मतलब two things. First thing, I want to ask user that you enter a new element, and at the same time I want to ask user at which position you want to enter that. So enter एंटर एलिमेंट पोजीशन, कि आपको कौन से पोजीशन पे वो एलिमेंट इंसर्ट करना है. सो आई एम टेकिंग टू थिंग्स फ्रॉम द यूजर, एंड ऑब्वियसली नाउ वी हैव वांट टू राइट अ फंक्शन add at position, and there will be two things. This value I want to put it at this position. So obviously I want to write a function list dot add at position. So let me write a function over there, and as we are written a function, there are two things. Which two things? Value and a position. तो लेट अस फर्स्ट अंडरस्टैंड ऑन पेपर कि एग्जैक्टली मुझको क्या करना है. ये वैल्यू इस पोजीशन के ऊपर ऐड करना है. तो पहले डायग्रामेटिकली क्या करना है, स्टेप नंबर 1. एंड वंस यू अंडरस्टैंड डायग्राम, देन द फर्दर स्टेप. So let us go ahead. The very first thing, can you please tell me what should be the first step of adding a node at the given position? Suppose that this is like a positioning 1, 2, 3, 4, and I'm saying that the new node that I'm trying to create, I want to add at the position number 4. Obviously the very first step has to be first create a node. हाँ, जब तक आपका नोड ही क्रिएट नहीं होगा तब तक ऐड करने का सवाल ही पैदा नहीं होता. Oh, I understand that, and that's why I should first allocate a memory, and I need to, let's say 500, let's say 55. It's done. So this is a new node that you want to create. That is my step number 1. A new node, let's say 500. Done. What is the next step? What is the next step? अब आपको क्या क्या modify करना है? Look at the diagram first, and first identify the areas which you want to modify. आपको क्या क्या change करना है इस diagram में? Take a look at this. आपको क्या क्या change करना है इस diagram में? अगर इस नोड को फोर्थ पोजीशन पे ऐड करना है तो चेंजेस क्या क्या होने चाहिए, कहाँ कहाँ पर चेंज होने चाहिए? एक तो नया जो नोड है उस नए नोड का नेक्स्ट चेंज होना चाहिए. यू अंडरस्टैंड इट वेरी वेल. आई एम सेइंग दैट नाउ दिस नोड शुड पॉइंट टू दिस. ये होना चाहिए, ये पहली चीज. और दूसरी चीज, अगर आपको उसको फोर्थ पोजीशन पे डालना है, अगर आपको उसको फोर्थ पोजीशन पे डालना है तो थर्ड नोड जो है उसके नेक्स्ट में ये नया वाला नोड आना चाहिए. And if you do that, just check, will it be the correct linked list? Is it what the output that you look for? हाँ, यस. पहले ये कंफर्म करो कि आपको करना क्या है. इसका मतलब मुझको दो चीजें चेंज करनी है. एक कौन कौन सी दो चीजें चेंज करनी है? पहली चीज जो मुझको चेंज करनी है, इसका नेक्स्ट मुझको मॉडिफाई करना है, वेयर इट शुड बी लेट्स से 400, और इसका नेक्स्ट मुझको मॉडिफाई करना है विच शुड बी द न्यू नोड एड्रेस प्रोबेबली 500. इट शुड बी न्यू नोड एड्रेस प्रोबेबली 500. दिस इज व्हाट आई नीड टू डू इट. चलो, if I understand this, let us go ahead and now think it more algorithmic way or programmatic way. तो दो चीजें अगर आपको मॉडिफाई करनी है, फर्स्ट ऑफ ऑल यू शुड बी हैविंग पॉइंटेड टू बोथ ऑफ देम. यू शुड बी हैविंग पॉइंटेड टू बोथ ऑफ देम. सो वेरी फर्स्ट थिंग, न्यू नोड का पॉइंटर तो मेरे पास होगा ही. व्हेन आई क्रिएट अ न्यू नोड, ऑब्वियसली आई विल बी हैविंग अ पॉइंटर टू द न्यू नोड. अब मुझको क्या चाहिए? अगर मुझे फोर्थ नोड पे ऐड करना है, देन आई नीड टू ऑल्सो गेट अ पॉइंटर टू द थर्ड नोड. How do I get a pointer to the third node? So you start with this. So you simply make that, you can take a pointer, let's say trav. You can say trav is equal to head, and then is it a third node? No, it is not a third node. Is it a third node? No, this is not a third node. So this is a third node. Yes, this is a third node. Somewhere you need to do the counting, and doing counting, you want to reach till the third node. You want to reach to the third node. So what is your step number 1? Step number 1 is allocate the new node and initialize it. Okay, good. What is step number 2? Step number 2 is traverse till position -1. Traverse till position -1. That is what you look for. That is second. And now tell me, एक आपके पास trav है, आपके पास new node है, अब आपको क्या करना है? What all things that you need to change? आपको दो पॉइंटर चेंज करने हैं. Which pointer I will change it first? Which pointer I should change it first? Which pointer I should change it first? Should I change new nodes next or travs next? Obviously, I should be first changing the new nodes next. I should be first changing a new nodes next. See the problem. अगर आपने गलती से अगर आपने पहले इसको चेंज कर दिया, if you just make that, if you make this as 500 and if this start pointing to this, what will happen? आपका जो आपका next node होगा, this node will be lost permanently. This node will be lost permanently. फिर इसके next में डालने के लिए एड्रेस कहाँ से लाओगे? So always remember that all I need to do is that जो भी आपका पहला नया नोड है, नए नोड के अंदर जो एड्रेस आपको ऐड करना है, जैसे 400, इसको पहले ऐड कर लो, इसको पहले ऐड कर लो, एंड once you added that, then you go back कि जो previous नोड था, इसको यहाँ पर ऐड कर दो 500 एंड देन yes my लिंक लिस्ट विल बी कंप्लीटेड. सो मुझको दो स्टेप करने हैं. न्यू नोड के नेक्स्ट में 400 डालना है, ए न्यू नोड के नेक्स्ट में 400 डालना है, which is by default available into the travs next is the first step. और दूसरी चीज, trav के next में 500 डालना है, which is available into the new node, absolutely right. A simple terminology. तो सर ये कैसे याद रखेंगे? सर पहला कौन सा करना है, दूसरा कौन सा करना है? अ वेरी बेसिक रूल जो हमको इलेक्ट्रॉनिक्स में पढ़ाया जाता था. इलेक्ट्रॉनिक्स में बहुत सारे टाइप के स्विचेस होते हैं. अगर आप, आई एम वेरी श्योर आप लोगों ने इतना इलेक्ट्रॉनिक्स फर्स्ट ईयर में पढ़ लिया होगा. एंड द टिपिकल अ स्विच टाइप वी कॉल इट द मेक बिफोर ब्रेक. What is make before break? You always first make the new connection before you break any existing connection. तो सर यहाँ पर क्या उससे लेने देना है? Have a look at this. Moment I say over here 500, अगर मैं यहाँ पर 500 कर रहा हूँ, प्लीज अंडरस्टैंड दैट आपका जो ओल्ड कनेक्शन था, ये कनेक्शन ब्रेक हो रहा है और ये एक नया कनेक्शन क्रिएट हो रहा है. ये नया कनेक्शन क्रिएट हो रहा है. सो आई एम सेइंग दैट यू आर ब्रेकिंग द ओल्ड कनेक्शन. आई ऑलवेज से दैट इट इज मेक बिफोर ब्रेक. मेक बिफोर ब्रेक का मतलब है पहले नए वाले कनेक्शन बनाओ, पहले नए वाले कनेक्शन बनाओ और उसके बाद में ओल्ड वाले कनेक्शन ब्रेक करो. दिस इज अ वेरी सिंपल रूल दैट यू कैन रिमेंबर थ्रू आउट द लिंक लिस्ट, थ्रू आउट द लिंक लिस्ट. सो जब भी ऐसे कंफ्यूजन हो, दो पॉइंटर चेंज करने, जहां पर भी कंफ्यूजन हो, दो पॉइंटर चेंज करने. ऑलवेज इंश्योर दैट जो भी नया नोड होगा उसके पॉइंटर्स पहले सेटअप करो, नए नोड के पॉइंटर्स पहले सेटअप करो और उसके बाद में एग्जिस्टिंग नोड के पॉइंटर्स वापस एक बार उनको ओवरराइट करो. दिस इज व्हाट ऑल यू कैन डू. इज द कंसेप्ट इज क्लियर? This is not only for this linked list, this is for throughout every linked list that we will be talking about. So don't forget that. And then I'm continuing further. Yes, it is a relay concept. तो सर क्या क्या करना है स्टेप्स? स्टेप क्या क्या करने हैं? स्टेप नंबर 1, what is that? Allocate and allocate and initialize new node. This is my first step. Okay, what is my second step? What should be my second step? The second step, traverse till position -1. I'm saying that using a trav pointer for that. Then next, what is the next step? The next step, अब मुझको दो पॉइंटर चेंज करने हैं. So I'm saying that new nodes next, new nodes next should point to travs next, right? You take a look at the diagram. New nodes next, अगर आप लोग ये इसको ट्रैव कह रहे हो, अगर आप इसको ट्रैव कर रहे हो तो ट्रैव का नेक्स्ट इज नथिंग बट 400. I'm saying that new nodes next should point to trav. New nodes next should point to the travs next. New nodes next should point to the travs next. Okay, I see that. And then last thing, यहाँ पर 500 आना चाहिए. So travs next should have address of the new node. You go back. Travs next should point to new node. Is it done? Yes, it is absolutely done. Now let us just go ahead, implement the basic stuff, and then we'll talk about special case, if any. So node, new node is equal to new node. You initialize that. Okay, I done initialization. Part one is done. Second part, how do I traverse till position minus one? Hey, why don't you write a normal loop for I is equal to one, I is less than position minus one, I plus plus. Okay, that is good. Simply say trav is equal to trav's next. Oh, that's it. Trav till trav is equal to trav's next. So I have taken care. Obviously, initially I should have first said trav is equal to head. So you start with the first node and you go till position minus one. This is done. Then you continue further. New nodes next. मेक बिफोर ब्रेक, तो पहले नया वाला लिंक बनाते हैं. न्यू नोड के नेक्स्ट में क्या आना चाहिए? ट्रैव का नेक्स्ट आना चाहिए. दैट्स इट. मैं फिर से एक बार रिपीट कर रहा हूं. न्यू नोड के नेक्स्ट में ट्रैव का नेक्स्ट क्यों आना चाहिए? अभी जो आपका ट्रैव है, अभी ट्रैव का नेक्स्ट 400 यहां पर पॉइंट कर रहा है. करेक्ट. सो न्यू नोड के नेक्स्ट में यहां पर जब 400 आएगा, यहां पर जब 400 आएगा, एट दैट टाइम यू कैन से दैट यस दिस इज पॉइंटिंग टू दिस. लेकिन यहां पर 400 आने के लिए ये 400 एड्रेस को कहां पर मिलने वाला है? ये 400 एड्रेस मुझको ट्रैव के नेक्स्ट में मिलने वाला है. तो जहां पर मिलने वाला है वहां से यहां पर ले रहे, बाकी कुछ नहीं कर रहे. मैंने ऑलरेडी इसको 4 बार रिपीट किया. Okay, go ahead. And the next one. Then you continue further. Trav.next is equal to new node. What is trav.next is equal to new node? अब यहाँ का 400 आपने ऑलरेडी यहाँ पर डाल दिया है, तो और कुछ करने की जरूरत नहीं है. ऑल आई नीड इज दैट यहाँ पर अब मुझको 500 एड्रेस चाहिए, सो दैट दिस विल स्टार्ट पॉइंटिंग टू दिस. बट यहाँ पर 500 एड्रेस कहाँ से आएगा? वो 500 एड्रेस इज नथिंग बट द एड्रेस इनसाइड न्यू नोड. I hope this is clear to everyone. And if this is clear to everyone, let us continue a step ahead. Let us continue a step ahead. By the way, is if you just do that, ये जो कुछ भी आप लोगों ने कोड में किया है, if you just follow that, ये फिर से एक बार, पहला स्टेप क्या था आपका? मैं और एक बार रिपीट कर रहा हूँ. कोड ये रहा. कोड शेयरिंग चल रहा होगा तो ज्यादा अच्छा होगा. You can just take a look at the code side by side. Step number one, node new node is equal to new node. So what you are doing? You are allocating memory for the new node, and whatever is the address, you are taking the address into the new node pointer is the first step. So you got the address 500 over here. Then you are also initializing that. Okay, initialization is done in a constructor. We have taken care of it. What is second step? You want to traverse till position minus one. So using this, ultimately your traverse till position minus one. Position minus one कैसे? यहाँ पर initially you start with trav is equal to head, and then you just say that 1 2 3. आपको सिर्फ काउंटिंग ही तो करना है, ये आपको लास्ट नोड पे नहीं जाना है. You want to traverse till position minus one, and that is the reason a simply written that for I is equal to 1, I is less than position minus 1, that is more than sufficient. टू बी फ्रैंक, आपको 3 नोड ट्रैवर्स करने ही नहीं पड़ते, क्योंकि जो इसका इस नोड का जो एड्रेस है, प्लीज मेक अ नोट, इस नोड का जो एड्रेस है वो यहीं पर अवेलेबल है. डोंट फॉरगेट. So actually we are just traversing it twice, and that is more than sufficient to get the address of the third node. Just make a note of it. Okay, and then you continue further. New nodes next is equal to trav next. A new nodes next is equal to trav next. A trav next is look like 400. So 400, that 400 I'm copying over here, it is pointing to this. That is my third line. And what is the last line? Last line is saying that trav.next is equal to new node. Trav.next, a new node kitna hai? 500. So 500 is copied over here. It is no more pointing to this, and this is my code. तो सर आपने पहले डायग्राम ड्रॉ किया, फिर कोड लिखा फिर से डायग्राम ड्रॉ किया. दैट वाज अ वेरिफिकेशन स्टेज कि जो हमने कोड लिखा है, इज इट गोइंग करेक्ट, नॉट गोइंग करेक्ट, और सो ऑन. But sir, do you find any special case over here? Yes, there can be multiple special cases. We will talk about one or two cases from that. We will talk one or two special cases for that. बचे हुए cases, you can do it as your homework. The very first special case that I just bother about, there are two special cases I consider. If head is null, if the list is empty. Can you please tell me if list is empty? The special case one, I'm saying that list is empty. अगर लिस्ट एम्प्टी होगी तो आपको क्या करना चाहिए? पहले लिंक लिस्ट आपकी है, डिसीजन आपको लेना है कि पहले क्या करना चाहिए उसका डिसीजन आप लोग ले लो, उसके हिसाब से कोड हम लोग लिखेंगे बाद में। माय क्वेश्चन इज दैट ये जो कुछ भी आप लोगों ने नया नोड क्रिएट किया है, इसका करना क्या है? इफ एट ऑल लिस्ट इज एम्प्टी, व्हाट आई शुड डू? What should I do? You tell me what is to be done. All I need to do is that I need to make that particular node as a first node. Okay, if you are saying that that particular node you want to make it first node, so वापस एक बार, तो सर हमेशा ऐसे होता है क्या? नहीं, लिंक लिस्ट आपकी है। जब लिंक लिस्ट आपकी है, डिसीजन आपको लेना है। When you are going to make your own linked list, it is your decision what exactly you want to do. So you just said that if list is empty, make node as first node. तो सर उसमें एग्जिस्टिंग कोड नहीं चलेगा क्या? सवाल ही पैदा नहीं होता एग्जिस्टिंग कोड चलने का, क्योंकि आप लोग यहाँ पर क्या कर रहे हो? यू आर ट्रैवर्सिंग टिल पोजीशन -1। अगर अगर आपकी लिंक लिस्ट एम्प्टी होगी, हाउ यू कैन ट्रैवर्स टिल पोजीशन -1? इट विल नॉट बी जस्ट पॉसिबल, it will not be just possible, and that code is going to fail. Yeah, I understand. Case number 1, case number 1 is very simple, where I consider that list is empty. Let me talk about the second special case. Please pay attention. Special case number 2. Special case number 2, where add at first position. Add at first position. That is, I'm simply saying that position is equal to 1. I believe that this is another special case. This is another special case. Isn't it? Isn't it? Again, जो लॉजिक आप लोगों ने लिखा है, लॉजिक, हेलो, लॉजिक, यू आर सेइंग दैट ट्रैवर्स टिल पोजीशन -1, बट अगर आपको पहले नोड पे लग जाना है तो यू वांट टू ट्रैवर्स टिल, हेड। ओ, बट प्रॉब्लम इज दैट हाउ डू आई ट्रैवर्स टिल हेड? देयर इज नो कोड अवेलेबल। प्लीज नोट दैट ये जो दोनों स्पेशल केसेस थे, ये जो दोनों स्पेशल केसेस थे, इन दोनों स्पेशल केसेस में आपको हेड मॉडिफाई करना पड़ता। अगर दोनों स्पेशल केसेस थे तो हमको हेड मॉडिफाई करना पड़ता। अगर आप लोगों ने ठीक से आपका कोड चेक किया है, इस कोड में कहीं पर भी हेड के चेंज का कोड ही नहीं है। इट इज वेरी क्लियर कि इन बोथ ऑफ दिस स्पेशल केसेस कोड इज नॉट गोइंग टू वर्क। तो सर और भी कोई स्पेशल केस होगी? वैसे टू बी फ्रैंक, स्पेशल केस और भी हो सकती है। देयर कुड बी वन मोर स्पेशल केस, वन मोर स्पेशल केस, one more special case. You can simply say that special case number 3, add node, add node beyond position. ए बियॉन्ड पोजीशन मतलब आपके पास टोटल 5 नोड्स हैं। अब बियॉन्ड पोजीशन मतलब आपके पास टोटल 5 नोड है। someone is saying that add at position number 6, add at position number 7, add at position number 8। अगर 5 ही नोड है तो पोजीशन नंबर 6 या 7 या 8 के ऊपर ऐड हो ही नहीं सकता। Again, what should be done in that case? What should be done in that case? Again, linked list आपकी है, choice आपका है। Linked list आपकी है, choice आपका है। You may say that we will throw the exception. If you say that you should throw the exception, go ahead, throw the exception. Someone says that नहीं नहीं sir, I don't want to give an exception. अगर अगर यूजर गलती कर रहा है, invalid position दे रहा है, still I want to add the node at the end. Choice is yours. So कौन सा बेटर है? आपकी लिंक लिस्ट है, आप डिसाइड करो। So few people might say that, sir, I want to throw the exception, write the code for that. Few people might say that, nahi sir, I want to add it at the end, write the code for that. Choice is yours. I repeat once again. तो उसे लिंक लिस्ट में कौन सा सही होता है? लिंक लिस्ट में सही या गलत कुछ नहीं होता। जब डेटा स्ट्रक्चर आपका होता है तो आप लोगों ने आपके रिक्वायरमेंट के हिसाब से कोड लिखना चाहिए। और इसीलिए मैं कहता हूं यू शुड नॉट फॉलो द बुक्स। वो बुक में जाते हैं, बुक में जाके कोड रखते हैं और फिर वहां पर आके लिखते हैं और कहते हैं कि नहीं नहीं लिंक लिस्ट ऐसा ही होता है। लिंक लिस्ट ऐसा ही नहीं होता है, आपके रिक्वायरमेंट के ऊपर डिपेंड होता है। यू मेक योर ओन रिक्वायरमेंट एंड देन यू इंप्लीमेंट योर ओन कोड, दैट इज द लॉजिक। तो चलो हम लोग जाते हैं। अब मैं, मेरे पहले दो केसेस का तो मेरे को क्लियर है, जो पहले दो केसेस का क्लियर है, लेट मी इंप्लीमेंट दैट। सो स्पेशल केस, special case 1, special case 1, what is that? If list is empty, add node at the start. Okay, that is good. Special case number 2, the special case number 2, if position is equal to 1 or I say that less than 1, less than 1, then again add node at the start. इन बोथ केसेस, तो सर दोनों में एक ही लॉजिक लिखना है, एक ही लॉजिक लिखना है। तो सर वापस से हेड इज इक्वल टू न्यू नोड करेंगे क्या? कर सकते हैं, बट आई पर्सनली बिलीव दैट इंस्टेड ऑफ rewriting the code, why don't we call the ready-made function? If we already have a function, so if head is equal to null, or if position is less than or equal to 1, less than or equal to 1, let me just make a call to the existing function instead of writing a new one. Otherwise, else you can think of going like a general case, add node at given position, add node at given position, like a else part, and into the else part I can write this logic. So will it work? Yes, that is more than sufficient. So special case number 3, I'm not doing that. I'm leaving it for you people if you are interested in. जिसको इंटरेस्ट होगा वो लोग करो. So you go ahead. एक कोड ऑलरेडी हम लोगों ने यहाँ पर लिख दिया है. So nothing much to be done. Let me just run the program. Let me run a program. Run. Let's say 3, 10, 3, 20, 3, 30, 3, 40. Hey, what is your current linked list? Oh, current linked list is 10, 20, 30, 40. Okay, that is good. Let me add the node at the given position. Position number, choice number 4. New node is, let's say, 50. At the position number, at the position number 4, at the position number 4, let me add it over there. And then ये मतलब 10, 20, 30 के बाद में ऐड होना चाहिए. 10, 30, 10, 20, 30 के बाद में 10, 20, 30 के बाद में 50 ऐड होना चाहिए. That is in front of you. It is working well. So और कुछ करना है और कुछ भी नहीं करना है. That's it. You continue further. You continue further. Let's say that what if you give the position? What if you give the position is equal to 1? So position is equal to 1. So you are trying to add the element at the beginning. Okay, let's say 60. I'm trying to add. Sorry, मैंने उल्टा किया. I written a element is equal to 1, position is equal to 60. You find that if I'm trying to write a position is equal to 60, definitely it is not working. So वो last वाला केस वैसे भी मैंने कंसिडर नहीं किया था. कोई बात नहीं है, फिर से एक बार ट्राई करते हैं. एड फर्स्ट वाला मैं काम करता हूँ, यही से शुरुआत करता हूँ. एडेड पोजीशन, एडेड पोजीशन, अभी मेरा लिंक लिस्ट एम्प्टी है. मेरा लिंक लिस्ट एम्प्टी है. आई एम सेइंग दैट आई एम एडिंग 10. आई एम एडिंग 10 एट द फर्स्ट पोजीशन. इज इट वर्किंग? ओ इट इज वर्किंग. तो मेरा जो पहला स्पेशल केस था, head is equal to null, that has been handled. Okay, you continue further. You try to add another new element, let's say 20 at position number 2. Oh yes, it is getting added at position number 2. आप लोग चेक कर सकते हो. Yes, 10 के बाद में 20 ऐड हो रहा है. So adding at the last position there is not a problem, but adding a position beyond that. अब मेरी लिंक लिस्ट में सिर्फ 2 नोड है, लिंक लिस्ट में सिर्फ 2 नोड है, और आप लोग कह रहे हो add what that, add the element 30 at position 10. 2 नोड में अगर आप लोग 10th पोजीशन पे जाओगे, दिस इज गोइंग टू थ्रो द एक्सेप्शन. सो आपको दिख रहा है ऑब्वियसली. अगर हैंडल करना है तो, हैंडल करना है तो आपको इस लूप में चेक करना चाहिए. अगर हैंडल करना है तो शायद आपको लूप में चेक करना चाहिए. चलो तो चलो वो भी मैं लिख ही देता हूँ, आपके लिए होमवर्क देने से अच्छा है. बेटर आई राइट इट, आई राइट इट देयर इटसेल्फ, सेइंग दैट इफ trav dot next is equal to null, I just simply say break. What I'm saying, special case number 3, special case number 3, if position is beyond beyond the length of list, then add node at the end. मेरी लिंक लिस्ट है तो मैंने कहा if at all I'm finding it next is equal to null, so मैं वहीं पर रुक रहा हूं, and obviously I'm trying to add a node after that. चलो, I hope you people have tried it. Go ahead and let me know if it is working for you. चलो गुड. So if it is going well, तो सर अभी आपने जो कोड मॉडिफाई किया है इसकी वजह से एक्सेप्शन नहीं आएगा क्या? आइडियली तो नहीं आना चाहिए. सो यू कैन ऑलवेज गो देयर एंड यू कैन ट्राई दैट एज वेल. जब तक आप लोग रन कर रहे हो तब तक मैं एक बार और क्विकली चेक कर रहा हूँ. सो 3, 10, 3, 20, 3, 30. 10, 20, 30, this is my linked list. And I'm saying that add at position, let's say 40. And 40, I'm giving a position 10. Obviously, 3 node का linked list है. मैं position 10 दे रहा हूँ, but it is not giving me the exception. But then where the node is added, in my case, the node is added at the end. The kind of code that I have written is following that. All right. So what we have done is all this. Now let us continue further. Let us continue further. What if you want to delete a element at the first position? If you want to delete an element at the first position, what all efforts that you want to take? Take a look at this. And can you please tell me diagrammatically? I hope these steps will be easier क्योंकि यहाँ पर ज़्यादा कुछ करने लायक नहीं है. Take a look at this. What if you want to delete a node at the first position? Take a look at the diagram and tell me एक पहला नोड अगर नोड मुझने डिलीट कर दिया, ये नोड अगर मुझको डिलीट करना है तो क्या होना चाहिए एज पर द डायग्राम? एज पर द डायग्राम क्या होना चाहिए? मैं आउटपुट नहीं पूछ रहा हूं, मैं कोड भी नहीं पूछ रहा हूं. प्लीज टेल मी इन इंग्लिश क्या करना चाहिए. Absolutely, in this particular case, head should start pointing to the next node. That's it. And if head is pointing to the next node, हम लोग जावा में हैं, you know it very well, this node will be then automatically garbage collected. If no one is going to refer that, by default this node will be garbage collected. So मुझको और कुछ करने की जरूरत नहीं है. अगर हम लोग C++ में होते हैं तो हमें जाके फ्री करना पड़ता है या डिलीट करना पड़ता है मैन्युअली. गुड थिंग अबाउट जावा इज दैट मुझको इसमें कुछ भी एफर्ट्स लेने की जरूरत नहीं है. ऑल आई नीड टू डू इज दैट जस्ट पॉइंट इट टू द नेक्स्ट नोड. दैट्स इट. और कुछ करने की जरूरत है? और कुछ भी करने की जरूरत नहीं है. हाँ बट रुको, इज देयर एनी स्पेशल कंडीशन टू बी कंसिडर्ड फॉर दिस? is there is any special condition to be considered for this? What is special condition? ये head is equal to head dot next हम लोग तब कर सकते हैं जब हमारी linked list empty नहीं हो. If linked list is empty and you write head is equal to head dot next, what will happen? In this case, what will happen? It will give me the null pointer exception. Oh, sorry, I don't want a null pointer exception. So I need to always check if the list is empty. If the list is empty, then do not try to delete. If list is not empty, then and only then I want to delete the first node. I want to delete the first node. That's it. तो सर एक बात बताओ, if list is empty क्या करना है आपको? स्पेशल केस में आपको करना क्या है ये तो बताओ. अगेन योर रिक्वायरमेंट क्या है? लिस्ट empty. If list is empty, in case of del first, what output that you're looking for? क्या करना चाहिए आपने? If list is empty and user is saying that delete that, अरे deletion चल रहा है कोड. Amit, we are into the function delete first function. So choices क्या क्या है? एक choice है ignore that. एक choice है ignore that. And choice number 2, throw the exception. Throw the exception. Choice is yours. या तो ignore करना है या तो exception देना है. It is up to you. So you may say that throw exception. If list is empty, you might want to throw the exception. Choice is yours. Okay, let us just go ahead and write a code. यहाँ पर वैसे कोड में लिखने लायक ज्यादा कुछ नहीं करना है. ये आपको सिर्फ क्या करना है, ये जो 100 है इस 100 की जगह पे आपको 200 करना है. ए where do you get 200? A 200 is already there in old heads next. 200 you already get into the old heads next. Simply write a line of code head is equal to head dot next so that this will start pointing to this. I repeat, इस नोड का मुझको कुछ भी नहीं करना है. क्यों? क्योंकि वो नोड when no one is referring that node, Java JVM will automatically garbage collect that. JVM will automatically garbage collect that. So hardly 2-3 lines of code we need to write it as far as del first is concerned. कहाँ पर गया? Add first हो गया, add last हो गया, added given position हो गया. Let me continue further. Public void del first and del first. What I want to say? If sorry, special case 1. If list is empty, throw exception. Okay, throw exception. And then general case, what is that? Make head pointing to next node. Done. So these are 2 lines of code. First line of code, if head is equal to null, simply you can say throw new exception. Throw new exception, runtime exception. You can say that whatever you want to write it. List is empty. I just written that message and I just left it. And a second one, in general, what I want to do it is hardly one line of stuff. Head is equal to head.next. Please note that the old what is that the old first node will be garbage collected since no one is pointing to that. So call करने के लिए कोई efforts लेने हैं? Not absolutely. Adelphus का केस कौन सा था? Case number 5. Go to the case number 5. Simply make a call list.del first and your first node is deleted. So will it throw the exception? Yes, it may throw the exception. If you're worried about it may throw the exception, go ahead, make a try catch block. And if at all there is an exception, just print that exception. That's it. All we can do. E dot, I'll say get message. All right, I'm done with this. So will this code work? I believe so. You can always try it at your end. Check if it is working. Let me go ahead. Let me run. ये पहले तो लिंक लिस्ट क्रिएट करते हैं. So 3, 10, 3, 20, 3, 30. Display. Oh, 10, 20, 30 is there. It is available. Let me say del first. 5. पहला नोड शायद डिलीट हो गया. You check. Oh, 10 is gone. Again 5. Again display. 20 is gone. 5. Again. Now there is nothing. 30 is also gone. So पहला भी डिलीट हो गया, दूसरा भी डिलीट हो गया, तीसरा भी डिलीट हो गया. सर अब क्या होगा? If I try to delete once more, अब क्या होगा? अभी आपका लिंक लिस्ट एम्प्टी बन चुका है. In this case, what will happen? At this time, it will throw the exception saying that list is empty and that exception I have printed over here. All right. Please check. Is it going well? I hope it was very simple. Let us continue further. Let us continue further. And to continue further, I want to delete a node at a given position. और एक काम करते हैं, पहले उससे सिंपल वाला है कि जो है वो लिख लेते हैं. Let's add, I want to delete all the nodes. How do you delete all the nodes? How I can delete all the nodes? Yes, Java में बहुत ही simple है. So in Java, all we need to do is that we need to just make the entire list eligible for the garbage collection. And just to make the entire list eligible for the garbage collection, all I am doing is that simply make head is equal to null. And moment you make head is equal to null, I say that all nodes will be garbage collected. वापस से जिन लोगों ने कभी C++ में डेटा स्ट्रक्चर किया होगा उन लोगों को पता है इतना आसान नहीं होता है. वहां पर यू नीड टू टेक एफर्ट्स, यू नीड टू राइट अ लूप. एक डेल फर्स्ट लूप में बार बार करना पड़ता है. लेकिन हम लोग जावा में, लेट अस टेक एडवांटेज ऑफ जावा, एंड जावा सेज दैट जस्ट मेक हेड इज इक्वल टू नल. सो आपका पहला नोड ही रेफर नहीं होगा, वो गार्बेज कलेक्ट हो जाएगा। ऑब्वियसली उसके आगे वाला भी गार्बेज कलेक्ट हो जाएगा, ऑब्वियसली उसके आगे वाला भी गार्बेज कलेक्ट हो जाएगा। सो ऑल दोज नोड्स विल बी डिलीटेड, दैट्स इट। सो सर एक आध क्विक एग्जांपल, क्विक चेक हो जाए, और क्विक चेक हो जाए, कोई बात नहीं। लेट्स से 3, 10, 3, 20, 3, 30. You see, oh, 10, 20, 30, 3 nodes are there. 3 nodes are there. You just go ahead, say 8, delete all. 8, delete all, and now find that my list is empty. Nothing to be done. Oh, why don't you try it? हार्डली एक लाइन का कोड लिखना है, तो मैं कोड इसके लिए शेयर नहीं करने वाला अलग से। हार्डली 1 लाइन ऑफ कोड टू बी रिटन। आई गेस अगर आप लोगों ने जावा कलेक्शन फ्रेमवर्क किया है, जावा कलेक्शन फ्रेमवर्क में इसके लिए कौन सा फंक्शन है? समवन रिकॉल? जावा कलेक्शन फ्रेमवर्क में सारे नोड डिलीट करने के लिए कौन सा फंक्शन है? समवन रिकॉल? ऐसा कोई फंक्शन नहीं है। इज इट रियली द फंक्शन रिमूव ऑल नेम? नॉट इवन रिमूव। Remove and remove all. Remove is for the removing at a given index. There is a function by the name clear. Go and check Java collection framework. Collection interface में check करना. Yes, Prathamesh, you are correct. So it's like a clear function. Clear function will clear everything. आप लोग चेक कर सकते हो, जावा डॉक्स आपके पास होंगे, ओपन करके देख सकते हो। आपका जो कलेक्शन इंटरफेस है उसके अंदर क्लियर नाम का मेथड अवेलेबल है। Okay, that is good. That is good. And then I want to continue further. I want to delete. आज का लास्ट फंक्शन हम लोग देखेंगे और उसके बाद में हम लोग रुकेंगे। Last function, I want to delete at a given position. So I want to give the position to the user, and I simply say delete at that position. I want to delete at that position. Let us just go ahead, and I want to delete at that position. So how do I delete at that position? Let us go back and say that I want to delete a node at the second position. I want to delete the node at the second position. This node to be deleted. ये क्या करना पड़ेगा? टेक अ लुक एट द डायग्राम एंड टेल मी क्या करना पड़ेगा। फाइनली क्या होना चाहिए? अगर मुझको ये वाला नोड डिलीट करना है तो फाइनली क्या होना चाहिए? व्हाट शुड हैपन? अगर मुझको ये वाला नोड डिलीट करना है तो फाइनली क्या होना चाहिए? इंग्लिश में बताना, कोड में मत बताना। यस तेजस, यू आर करेक्ट। आइडियली यहां पर 300 आना चाहिए, सो दैट दिस विल स्टार्ट पॉइंटिंग टू द नेक्स्ट नोड। अगर आपको, इफ यू वांट टू डिलीट द नोड एट द सेकंड पोजीशन, सिंपल लैंग्वेज, फर्स्ट पोजीशन के नोड के नेक्स्ट में थर्ड पोजीशन के नोड का एड्रेस होना चाहिए, राइट? सो इसके नेक्स्ट में अभी जो 200 है वो 200 नहीं होना चाहिए, इसके नेक्स्ट में 300 होना चाहिए, सो दैट द नोड of the second position will get deleted. Okay, that is good. But the question is, how do I implement this? The question is, how do I implement it? Obviously, I can say, listen carefully. मैं एक थोड़ा सा अलग तरीका बता रहा हूँ जो यूजुअली मैं नहीं बताता. So it's like a different way I'm trying to tell you. So what is the different way? All I'm saying is that you traverse, listen carefully, you traverse till position. You traverse till position. अगर आपको second node delete करना है, please traverse up to the second node. Now what is the problem? The problem is that if you traverse till the second node, will it solve your problem? If you traverse till the second node, will it solve your problem? The problem is that आपको second node तक traverse करोगे, आपको second node को modify नहीं करना है। सेकेंड नोड के जो पहले वाला नोड है आपको उसको मॉडिफाई करना है। सो व्हाट आई एम सेइंग इज दैट उसके पहले वाला जो नोड है मुझको ये मॉडिफाई करना है। सो इफ एट ऑल आई एम गोइंग टू द नेक्स्ट नोड, going to the node to be deleted, it is of no use. I actually need a node before that. I actually need a node before that. Yeah, I hope I'm audible. Good. Okay, हाँ फाइन। सो आई एम कंटिन्यूइंग फर्दर। व्हाट आई एम सेइंग इज दैट, तो सर ये शायद इतने छोटे एग्जांपल में आपको समझ में नहीं आएगा, सो आई विल टेक अ बिट बिगर एग्जांपल। Suppose I'm drawing a simple linked list now. This like is a head node. Head is pointing to, let's say, 11. This is pointing to 22. This is pointing to 33. This is pointing to, let's say, 44. This is pointing to, let's say, 55. And this is pointing to null. What I want to do is that I want to delete this node. I'm interested in deleting this node. If I want to delete this node, I can always write a code. I can always write a code to traverse till the position. This node, let me traverse position 1, 2, 3, 4. I traverse till the position number 4. But what I'm saying, if I traverse till this particular position, this is of no use to me. This is of no use to me because actually जो modify करना है, modify इसको नहीं करना है. Modify किसको करना है? जो उसके पहले वाला node है उसको modify करना है. That is actual our requirement. That is actual our requirement. तो सर एक काम कर सकते हैं. We can traverse till position -1. I know that we can traverse till position -1, but instead of that, I'm just trying to look for some different trick. The trick that probably help you, while learning trees. तो position -1 से traverse करके आप लोग कर ही सकते हो. I know that, but I'm telling you one more trick. See, the trick is something like this. We will have two pointers. One is a trav pointer. See it carefully. One is a trav pointer, and another is, let's say, temp pointer. There are two pointers. One is a trav pointer, and another pointer, I can say, temp pointer. What I want the temp pointer to be move before trav pointer. तो सर ये कैसे होगा? I'm saying पहले temp को यहां पर लेके आओ and then take trav to the next. Again continue, temp को यहां पर लेके आओ, take trav to the next. Again temp को यहां पर लेके आओ and then take trav to the next. What I will ensure is that when trav is pointing to this node, temp is pointing before that node. And if temp is pointing this before this node, what all I need? I simply need that ये जो temp है, इसके next में ये जो trav है, इसके next का address जाना चाहिए. Do you visualize this? Yes, absolutely correct, Poonam. Temp के next में trav के next का address जाना चाहिए. Don't worry, मैं repeat करता हूँ वापस एक बार. मैं फिर से एक बार repeat कर रहा हूँ. What I'm saying is that instead of having two pointers, instead of using one pointer, I will use two pointers. This is a pointer that I want to traverse. A trav is equal to head से शुरू करेंगे. But this pointer, I'm saying, is the previous pointer, or let's say temp pointer. Now every time I'm saying that trav is equal to trav or next. Every time I'm saying that trav is equal to trav dot next, before trav going to the next node, I say temp is equal to trav, and then trav is equal to trav's next. Again you continue further, temp is equal to trav, and then trav is equal to trav's next. Again temp is equal to trav, and trav is equal to trav's next. What this will give me? By the time trav reach to the position, the temp is going one line behind it. Oh, temp is going one line behind it. Now what I need to do? All I need to do is that whatever is the address into this node, whatever is the address, temp के next में जो भी pointer है, जो भी address है, that I want to put it into the temp's next. That's it. This is my temp. This was my trav, and it is done. It is hardly a simple logic that we are writing. Why not you go there and try to implement a basic case? Logic क्या है? I'm saying that I am trying to traverse with two pointers, but I'll write it step by step. So your step number 1, traverse till position using trav, correct? But at the same time, take temp pointer traversing behind trav pointer, right? So how do we implement it? Let us just go ahead and simply say node temp is equal to null. initially temp is equal to null and trav is equal to head. यहाँ तक कोई प्रॉब्लम नहीं आना चाहिए. I'm saying for you want to traverse till the position I is equal to 1, I is less than position. अब मैं less than -1 नहीं लिख रहा हूँ. I'm saying that I is less than position and I plus plus. What I want to do? I want to simply say trav is equal to trav's next. But I want to maintain a pointer which is traversing behind temp pointer, which is running behind a trav. I'll keep it simple word, running behind trav. Okay, so every time I'm going to the next node, first say temp is equal to trav, first say temp is equal to trav, and then say trav is equal to trav's next. First say temp is equal to trav, and then say trav is equal to trav's next. That's it. So in this way, at the end of the loop, the trav is node to be deleted and temp is node before that. अब क्या करना चाहिए? Simply you want to bypass that particular trav node. So simply go ahead and say that temp's next is equal to trav's next. Temp's next is equal to trav's next. It is in front of you. Is this all right? Is this all right? सर उस नोड को डिलीट नहीं करना है. Please note the trav node will be automatically garbage collected. Will be garbage collected. आपको डिलीट करने के कष्ट नहीं करने हैं. It is that easy. But by the way, ये कोड फेल कब होगा? इस कोड में what would be the special conditions? Can you guess the special conditions, please? What would be the special condition? If your list is empty, you need not to traverse. Second special condition, you are trying to delete the node at the first position itself. You're trying to delete the node at the first position. Why you are traversing? Oh, that is again not needed. And third thing, if the position itself is invalid position, so there are plenty of cases. अब एक मिनट एक बात बताओ, if the position is invalid, what do you want to do? If position is invalid, what do you want to do? I'm very sure you do not want to delete that, no? ऐसा नहीं कि position अगर गलत है तो last node को delete कर देते हैं. No, that is not a good idea. I want to throw the exception. So let us just go ahead and put it over there one by one. So special case number 1, if list is empty, if position equal to 1, delete first node. Correct. The special case number 2, if list is empty or position is less than 1, then throw exception. And third thing, if what is third special case? Special case number 3, if position is beyond list length, what is to be done? Then again throw the exception. You continue further. You start with the first. If position is equal to 1, you simply want to make a call to the function, let's say del first. Oh yes, you can handle that, not a problem. You continue further. If head is equal to null or position is less than 1, you want to throw the exception. How do you throw the exception? Oh, we already know that. It is through the exception. I can simply say that list is empty or invalid position, whatever. That we are done. And a third thing, agar if you are going beyond the position, 100% your trav is already becoming null. If trav is null, again you want to throw the exception saying that this position is not available. So you can simply say invalid position. That's it. So will it work? Yes, it will work. आप लोग जब लैब में जाओगे आप इसको रन करके देख सकते हो. मैं फिलहाल एक बार क्विकली यहाँ पर रन करके दिखाता हूँ. लेट्स दैट 3, 10, 3, 20, 3, 30, 3, 40. You see display or 10, 20, 30, 40. Let me delete the node at the third position. I delete the node at the third position. 7. Delete the node at the third position. You find that, oh, 30 is gone. Now it is only 10, 20 and 40. I hope this is working well. इसको ट्राई कैच में लिखना है वो आप लोग लिख सकते हो. There is absolutely no problem. Is this all right? Is this comfortable? So this is all about how we go for a single linked list. I know that I have taken enough slow for this linked list, and I would say that I know that आज आपका 31st होगा, कुछ बहुत बड़े बड़े काम रहेंगे. So ensure that before you do anything else, linked list paperwork and its code, make yourself comfortable. If you do not get time, very important, if you do not get time to do the paperwork and write the code, do not come for tomorrow morning session. Tomorrow morning session is only for those people who have completed this part. So जिन लोगों का पेपर वर्क, सर हमको पेपर वर्क करने के लिए टाइम ही नहीं मिला, वो 31st के पार्टी में रह गया, तो don't come for tomorrow's lecture. Then your party should continue even till tomorrow. Don't come for tomorrow's session. It will be wastage of your time, your frustration and my frustration as well. Correct? Any questions are there? If someone has got a question, you can wait. If you have no questions, you can leave. Thank you very much. See you tomorrow on a new year. Bye bye.